If there is one place in the solar system that may be better for life than Mars, it may not be a planet at all. It may be Enceladus, a small icy moon of Saturn, hiding a global ocean beneath its frozen surface. In this video, the story follows why this distant world may offer liquid water, chemical energy, and the conditions life needs even more clearly than Mars does today. If this kind of calm space journey is worth exploring, please like the video, subscribe to the channel, and settle in. The story begins far from the Sun, in the broad outer reach of the solar system where light arrives thinly and slowly. At this distance, the Sun still rules,
small moon in a giant
but it does so with a weaker
can
hand.
still become one of the most
Its
compelling
warmth
life
is
search
reduced,
targets.
its light is softer, and every exposed surface must answer to a colder balance between incoming energy and the blackness of space. Saturn circles the Sun at an average distance of about 1.4 billion kilometers, or about 9.5 times farther from the Sun than Earth. Sunlight takes about 80 minutes to travel that span. In this remote setting, the whole Saturn system exists under conditions that seem, at first glance, deeply unfriendly to life. Saturn itself offers little comfort to such a search. It is a giant world made mostly of hydrogen and helium, without a solid surface on which liquid water can rest in any ordinary
Mars
way.
offers clearer skies
Pressure
for direct
rises
inspection,
downward
but
into
the subsurface
depths
ocean
that
of
no familiar
Enceladus may
living
hold the
thing
true
could
promise
tolerate,
for life.
and temperature changes with depth through layers of cloud, gas, and fluid. Around it, however, lies a far more varied family of worlds.
Easier to explore,
Saturn holds an
but
extensive
which one
system
harbors
of
the
moons,
conditions?
and these moons do not all share the character of the planet they orbit. Some are dark and battered, some are larger and wrapped in thick haze.
The comparison
some are
isn't
bright
between a
with
dead
water
Mars
ice
and a living
in
Enceladus,
the outer solar
but between
system.
two
Moons
astrobiological
begin
prizes.
to matter as much as planets. They carry local histories, local materials, and local possibilities. Among these moons, Enceladus is small. It is only about 500 kilometers across, much smaller than Earth's moon and much smaller than Mars. From a great distance, it does not look like a likely place for biology. It appears as a bright, icy body close to Saturn, one member of a wider system of rings and satellites. Yet the first lesson of this outer region is that size alone does not decide scientific importance. A small world can still occupy a critical position if its materials, orbit, and surroundings place it in a special environment. Enceladus circles Saturn between the moons Mimas and Tethys, moving within the densest part of the wide and faint E-ring. It keeps the same face turned towards Saturn as it travels, completing one orbit in a little less than 1.5 Earth days. Enceladus stands in a setting shaped by constant gravitational order. Seen only from the outside, Enceladus looks almost too bright to be interesting. Its icy surface reflects an extraordinary amount of sunlight, making it one of the most reflective bodies in the solar system.
Regions
that
stand
brightness
in
is
sharp
not a sign
contrast
of
to the
warmth.
ancient,
It
cratered
is almost the
foreground.
opposite. So much
The
sunlight
northern
is sent back
regions of
into space
Enceladus
that the
reveal
surface
a
remains
stark
extremely
contrast.
cold,
Ancient,
near minus
heavily cratered
201 degrees Celsius on average. In such conditions, exposed water freezes into hard ice, and the outer face of the moon seems locked into stillness, far from the sun, small, white, frozen, and airless. Enceladus seems less promising than Mars, which is larger, nearer, and long familiar as a place where rivers once shaped the land.
In orbital resonance with Dione,
Mars enters the
Enceladus
comparison
undergoes
from a very
powerful
different part
flexing.
of the solar system, and from a very different scientific
The orbital
tradition.
resonance with Dione
It orbits
creates
much
intense
closer to
tidal
the
heating
Sun
deep
than
within
Saturn
Enceladus.
does, at about 1.5 astronomical units. It is a rocky planet with valleys, volcanoes, sediment, polar ice, dust storms, and a thin atmosphere made mostly of carbon dioxide. For generations, it attracts attention because it resembles Earth more than the giant planets or icy outer moons do. It has a day of familiar length,
These are the tiger
seasons,
stripes,
weather,
active
and
fracture
ancient
zones
landscapes
in
that
the
preserve
south
the
polar
marks
terrain.
of flowing water. In outward appearance, Mars seems the easier place to imagine as a home for life. It presents a surface world, and life on Earth is known first from surfaces and shallow waters. The search for life therefore begins for many people with a simple instinct: look for another Earth-like ground under an open sky. That instinct explains much of Mars's power in the human imagination, but the outer view already begins to complicate it. Present-day Mars is not warm and wet. Its atmosphere is too thin for liquid water to remain stable for long on the surface, and much of the planet is a cold, dry desert exposed to radiation and to large temperature
Saturn's
swings.
E-ring is unique,
The
a
evidence
vast
from
torus
Mars
of
is
icy
strong that it
particles
was
replenished
wetter
by
and
the
more
continuous
hospitable
eruption of
billions of years
Enceladus'
ago.
south pole.
Ancient river valleys, lake beds, and water-shaped minerals preserve that earlier chapter, but the same evidence also shows
This fly-through
change
offers
and
a
loss.
rare chance to
Mars
gather
is compelling because it
interior-related
records a
material from an
habitable
ocean
past.
world directly in space.
Enceladus, by contrast, belongs to a region that looks hostile from the outside, yet may not fit the old rule that greater distance from the Sun means lower biological interest. This is the central adjustment that the Saturn system asks of planetary science. Habitability does not depend only on being near the Sun, or on having an atmosphere and an exposed rocky surface.
This
Those
active
factors
venting
matter
reveals
greatly for
Enceladus'
Earth,
south pole
and
as
they
a
matter in
tectonic
any
gateway.
general account of life as it is known, but they are not the only path to stable water and active chemistry. In the outer solar system, the environment broadens the definition of a promising world. The search stops asking only where sunlight is strongest, and starts asking where useful energy, liquid water, and
both the
chemical
vapor and the
ingredients
ice
might
cream.
persist under other conditions. From this outer vantage, the comparison with Mars becomes less a contest between a warm place and a cold one, and more a comparison between two different ways a world can carry the conditions relevant to life. Mars is open, exposed, legible on the surface, and marked by the memory of a wetter age. Enceladus is distant, icy, highly reflective, and outwardly severe, but it belongs to a planetary system where the small moons can diverge sharply from first impressions. Saturn is not habitable, yet some of its
These
moons remain
silica-rich
serious
particles provide the
candidates in the
strongest
search for
evidence yet of
environments that might
hydrothermal
support
activity.
life. This alone changes the meaning of distance. Farthest from the Sun does not always mean farther from possibility. In the cold architecture of the Saturn system, the search for life becomes quieter and less intuitive. It leaves behind the assumption
Cassini
that
mission
life must
revealed
prefer the
Enceladus
familiar
possesses
face
a
of a rocky
subsurface
surface
ocean,
under a thin
indicated by the
sky,
surprisingly
and
thin
begins instead with a small bright moon moving through the dim light beyond the asteroid belt. Enceladus does not drift around Saturn in stillness. Its path is orderly, but it is not perfectly simple. The moon moves in a slightly stretched orbit rather than a perfect circle, and that small difference matters. As Enceladus travels around Saturn, the giant planet's gravity does not pull on it with exactly the same strength at every point along the way. The pull grows a little stronger when the moon is nearer, and a little weaker when it is
The
farther
plumes
away.
vent chemically rich
This
samples from a
repeated
hidden global
change is
ocean,
gentle
making
in
Enceladus
appearance
one of
but
the clearest
powerful in
ocean world
effect.
candidate in the
It
solar
causes
system.
the moon to flex.
This cutaway reveals
its shape
Enceladus'
shifts by
hidden
a small
ocean,
amount again
a rich
and
source
again,
of dissolved
and that
materials
shifting
far
turns
beneath
orbital
the icy
motion
shell.
into heat inside the body.
Deep beneath the
This
ice of
process is
Enceladus,
called tidal
we find
heating.
not just water,
A
but the
tide,
ingredients
in this
necessary for
sense,
habitability.
is not limited to moving water. It means a response to gravity that stretches and squeezes a body. On Earth, the moon and the sun raise tides in the oceans and also smaller tides in the solid ground. On Enceladus, Saturn raises tides through the whole moon. Ice and rock are not perfectly rigid. Over time they bend, strain, and give way by tiny amounts. Each cycle of deformation wastes a little mechanical energy
This
as
equilibrium
internal
is central
friction.
to habitability,
That wasted
because usable
motion
energy
becomes
depends
warmth.
on chemical contrasts
The effect
rather than
depends on
chemical
more than
sameness.
distance alone. If Enceladus moved around Saturn in a perfectly circular orbit, the tidal pull would remain much more constant, and the amount of flexing would be much smaller. The crucial fact is that the orbit stays slightly eccentric, which means slightly off circle. That eccentricity is not simply left over from the past. It is maintained by an orbital resonance with another moon, Dione. In broad terms, resonance means that two orbiting bodies repeat a gravitational pattern in a regular numerical relationship. For Enceladus and Dione, that relationship is close to 2-to-1. Enceladus goes around Saturn about twice for each orbit of Dione. With every repeated alignment, Dione gives a small gravitational nudge that helps preserve Enceladus's orbital stretch. Without that repeated forcing, Enceladus would tend to settle into a calmer path. Over time, tidal effects themselves usually act to reduce eccentricity, smoothing an orbit toward a more circular shape. If that happened completely, the flexing would fade and the supply of heat would weaken. The resonance prevents that easy quieting. It feeds the process just enough to keep the orbit from becoming too regular. In this way, the Saturn system does
Deep
not merely
beneath the ice
contain
shell lies a
Enceladus.
global ocean,
It
where water
actively
circulates
works on
through
it.
a porous,
The moon's
mineral-rich
present
core.
state is linked to the larger gravitational architecture around it. This is an important change in perspective. Heat on a small distant moon does
Deep
not have
beneath
to
the
come
waves,
mainly from
water
sunlight.
permeates the rocky core
In the
through
outer
a
solar
vast
system,
circulation network.
sunlight is too weak to
This-
explain active geology on an icy body like Enceladus. Nor is ordinary leftover heat from formation likely to account for all that has been observed over long spans of time. The moon is small, and small worlds tend to lose internal heat more readily than large
Deep beneath
ones
the
because they
hidden
have
sea,
less insulated
water-rock
volume in
reactions
relation to their
release
surface
molecular
area.
hydrogen, a
For
crucial energy
Enceladus
source.
to remain active, an additional source of energy is needed. The orbital system provides that source. Motion itself becomes a resource. The energy does not appear everywhere in equal measure. Models and observations indicate that the heating is concentrated more strongly in some regions than in others, especially where material properties, shell thickness, and internal boundaries
While
allow
Mars
strain
offers
to build
clues
and
to
release
ancient
more
life in its
effectively.
exposed
The
basins.
exact distribution remains an active scientific problem, and researchers do not claim that every detail is settled, but the broad conclusion is strong. Enceladus is not a dead ice ball passively stored in the cold. It is a moon whose orbit continually drives internal work. This matters because a world does not need a thick atmosphere or direct solar warmth
The
to maintain
hydrothermal vents
environments
release
of
plumes rich in
astrobiological
hydrogen,
interest.
evidence that makes
It needs
Enceladus
energy
a strong
that
candidate
persists
for
over
ocean
long
habitability.
spans, and energy that can interact with matter rather than simply passing over the surface. Tidal heating does exactly
While Mars
this.
requires deep drilling
It
for
is not a
past
brief
traces,
event
Enceladus
like an
offers
impact.
direct access to a
It is
subsurface
rhythmic
ocean,
and
making it a
repeated,
prime candidate for
tied
present-day
to the
life.
moon's motion around Saturn. Each orbit renews the strain. Each cycle adds another small amount of heat. Over time,
Enceladus
the total
may matter
becomes
more than
significant.
Mars for present-day life.
The scale
because
is
it
easier
appears
to
combine
understand
liquid
when
water,
seen as
heat,
accumulation rather than as a single dramatic pulse. No single flexing event transforms Enceladus. The moon is warmed by repetition, hour after hour, orbit after orbit. The interior is worked by Saturn's gravity and by the resonant timing imposed through Dione. Over thousands, millions, and perhaps much longer spans of years. This repeated stressing can maintain internal warmth that would otherwise be lost to space. The process does not make Enceladus warm in any Earth-like surface sense. The exterior remains intensely cold. But beneath that frozen exterior, the thermal story can be very different. Scientists have also considered whether radioactive decay inside the rocky part of the moon
one of the most
may
compelling
contribute
life
some
search
heat.
targets.
That contribution is plausible, especially early in the moon's history and perhaps at a lower level today. Yet the leading explanation for the ongoing activity associated with Enceladus remains tidal heating. It best matches the basic fact that the moon's energy source is linked
Beneath
to its
this icy
orbit
shell,
and to its place
Enceladus
within
hides a
Saturn's
global
system.
ocean.
The moon is small, but it is not isolated. Its warmth is relational. It depends on being held in a repeating gravitational conversation with Saturn and Dione. For the comparison with Mars, this process is quietly decisive. Mars receives more sunlight than Enceladus, and it once had a thicker atmosphere and more abundant surface
Mars
water.
offers clearer skies
But
for
present-day
direct
Mars
inspection,
no longer has
but
a
the
strong
subsurface
global
ocean of
internal
Enceladus
engine of this
may hold the
kind
true promise
connected to
for life.
orbital forcing. Enceladus does. The outer solar system therefore offers a different logic of habitability, one less dependent on solar
The question
closeness
is not which
and more
world is
dependent
easier to
on sustained
explore,
internal energy.
but which one harbors the
At this
conditions?
stage, the argument is not that life exists there. It is only that the moon possesses a continuing source of heat capable of resisting
The
complete
comparison isn't
freeze-out.
between a dead Mars
In
and
a
living
region where
Enceladus,
cold
but
seems
between
final,
two astrobiological
orbital
prizes.
motion keeps opening a thermal possibility inside the ice. From the scale of the Saturn system and the deep influence of orbital motion, attention now rests on the outer skin of Enceladus itself. What appears first is not darkness, but whiteness. Enceladus is one of the brightest known bodies in the solar system. Its surface is made largely of water ice, and that ice reflects most of the sunlight that reaches it. In visible light, the moon looks clean and pale, almost luminous against the darker surroundings of space. This brightness is not a decorative detail. It is one of the clearest signs that the surface is unusual. A bright surface tells a simple physical story before it tells a geological one. When a body reflects much of the light falling on it, it absorbs less energy and stays colder. On Enceladus, this effect is strong. The moon receives only a small fraction of the sunlight that falls on Earth, and then reflects much of that small amount back into space. The result is an exterior of extreme cold. Across much of the surface, the ice remains hard and stable, locked under temperatures far below the freezing point of water. The whiteness therefore belongs to a severe environment. It does not suggest softness or thaw at the
These smooth,
surface.
resurfaced
It
regions
suggests
stand in
preservation
sharp
under cold
contrast to the
conditions,
ancient,
where
cratered
ice can
foreground.
remain exposed without melting into
The
liquid
northern
form.
regions of
Yet the
Enceladus
same
reveal a
whiteness
stark
also points
contrast.
to motion and renewal.
Ancient, heavily
In
cratered
planetary science, a surface is read partly through its scars. Over long spans of time, exposed worlds collect impact craters. Meteoroids strike them, and those impacts remain unless later processes erase or bury them. A very old and inactive surface usually carries many overlapping marks. A younger surface, or a surface that has been renewed,
In orbital
often
resonance
shows
with Dione,
fewer craters and
Enceladus
sharper
undergoes
geological
powerful
textures.
flexing.
Enceladus does not present one
The
uniform
orbital
face
resonance
in
with
this regard.
Dione creates
Some
intense
regions
tidal
are more
heating
heavily
deep within
cratered,
Enceladus.
But large portions of the moon appear strikingly fresh. They show relatively few impact scars and broad expanses of bright ice that seem to have been reworked after older terrain had already formed. This matters because small icy moons are often expected to cool, harden, and keep the ancient record of impacts without much change. Enceladus does not fully
These
behave
are the
that
tiger
way.
stripes.
Its surface
Active
carries evidence
fracture
that old
zones
material
in
does
the
not
south
always
polar
remain
terrain.
untouched. Some landscapes appear wrinkled, ridged, grooved, or smoothed in ways that suggest geological activity rather than simple passive aging. The eye sees brightness first, but scientific interpretation quickly reaches further. The brightness is not only about reflective ice. it is also about the relative newness of much of that ice. The word young in this context needs care. It does not mean recently formed in a human sense. It means young relative to the age of the solar system and young relative to older surrounding terrain. Planetary surfaces can be called young when they have been resurfaced late in their history, even if that resurfacing happened millions of
Saturn's
years ago or
E-ring is
continues
unique,
in
a
complex
vast
cycles.
torus of icy particles
On
replenished by the
Enceladus,
continuous eruption of
crater counts and
Enceladus's
surface
south pole.
textures indicate that some areas are much younger than others. Scientists do not claim that every region formed at the same time or by the same process.
This fly-through
The
offers
moon
a rare
preserves a
chance to
mixture of
gather
older battered terrain
interior-related
and
material
fresher
from an
terrain
ocean
that has
world
not had as
directly
long
in
to
space.
accumulate impacts. This mixed surface makes Enceladus more informative than a uniformly ancient ice ball would be. It means the moon has a geological history written across its exterior in contrasting layers of age. Some terrains remain as records of long exposure, others appear reset. The contrast itself becomes evidence. Something has modified the surface after the
This
period of
active
a heavy
venting reveals
bombardment that
Enceladus's south
shaped
pole as a
many
tectonic
outer solar
gateway.
system bodies. Something has laid down or exposed bright water ice in ways that reduce the visual dominance of old craters. At the scale of the whole moon, this resurfacing changes the meaning of the exterior. The surface is not only a
This
frozen
stunning view
shell
highlights
separating
the
space
plume's
from the
water-dominated
interior,
nature.
it is also an
Both the
archive
vapor
of
and the ice
exchange
grains
between past and present conditions. New ice at the surface does not arrive by chance. It points to transport, deformation, or reworking of material. The exact pathways differ across studies and regions, and scientists remain cautious about how to assign each landform to a single cause. Still, the broad picture is stable. Enceladus has been active enough to refresh significant parts of its outer face. This is one reason the moon becomes so important in the wider search for habitability. Mars offers a surface that clearly records ancient water, but much of its present exterior is dry.
These silica-rich
dusty,
particles provide the
and
strongest
long
evidence yet
exposed.
of hydrothermal activity.
Enceladus offers something different. Its surface is not friendly in the ordinary sense. It is colder, smaller, and almost airless. But its exterior appears less like a relic and more like a maintained boundary. Fresh ice suggests that the outermost layer
The
has
Cassini
not been
mission revealed
abandoned to deep
Enceladus
time.
possesses a
It
subsurface
is still
ocean,
being shaped,
indicated by the
directly or
surprisingly thin ice.
indirectly, by the moon's continuing history. The appearance of clean ice also affects chemistry at the surface. Pure or nearly pure water ice reflects light efficiently, and fine-grained ice can look especially bright. Grain size, texture, and contamination all matter. Darker material mixed into ice usually lowers brightness. On Enceladus, the high reflectivity indicates that the outermost layer contains abundant clean ice and relatively little dark debris over large areas. This is noteworthy because many small bodies in the solar
plumes vent
system
chemically rich
accumulate
samples
darkening
from a hidden
material
global
over
ocean,
time from
making
radiation
Enceladus one of the
processing,
clearest ocean world candidate in the
micrometeoroid
solar system.
bombardment,
This
or the
cutaway
exposure
reveals
of non-ice
Enceladus's hidden
components.
ocean, a rich
Enceladus
source of
seems
dissolved
able,
materials
at least
far
in many
beneath the
places,
icy shell.
to resist that long darkening trend.
Deep beneath the ice of
Its
Enceladus,
surface keeps
we
returning
find
to a
not just
cleaner
water,
state.
but the
A
ingredients
surface
necessary
like
for
this
habitability.
produces a quiet scientific impression. It does not merely survive in the cold, it is renewed in the cold. That distinction matters. The outer ice of Enceladus is not the kind of shell that can be understood only as frozen waste above a dead interior. Its brightness, freshness, and uneven crater record all suggest a moon whose exterior remains connected to active processes. At this stage, the evidence remains entirely on the
This
outside.
equilibrium is central
No
to
claim about
habitability
life follows
because
from
usable
bright
energy
ice alone.
depends on chemical
No
contrasts
direct
rather
conclusion
than
about
chemical
habitability rests on crater counts or reflectivity, but the surface changes the terms of the search. It shows that Enceladus is not only cold, it is dynamically cold, an icy world whose outer face bears the marks of continuing renewal. Near the south pole of Enceladus, the bright surface changes character. The ice there is not arranged only in broad plains or in the mixed pattern of craters and smoother terrain seen elsewhere. Instead, the ground is cut by a small set of long, nearly parallel fractures that stand out from the surrounding landscape. These features are commonly called the tiger stripes because of their visual pattern, dark and linear against the brighter icy terrain around them. The informal name is memorable, but the scientific importance lies in what these fractures reveal about stress, heat, and the special nature of the South Polar region. The fractures are large features on a small moon. They extend for many tens of kilometers and are bordered by ridges and trough-like forms that give the terrain a broken, organized appearance. Rather than a random field of cracks, the region presents a structure with repeated direction and spacing. This order matters. On a planetary body, repeated geometry often points to repeated
Deep
forces.
beneath the ice shell lies a
The
global
tiger
ocean,
stripes are not
where
simple
water
scratches
circulates
on
through
the
a
surface.
porous, mineral-rich
They
core.
are part of a system of deformation, places where the ice shell has responded in a sustained and localized way to the stresses acting on Enceladus.
Deep
The
beneath
South
the
Polar
waves,
terrain
water
differs from many
permeates the
older
rocky
parts
core
of the
through a
moon.
vast
It is younger
circulation
in
network.
appearance,
This
with fewer obvious impact craters than would be expected on a fully ancient and inactive surface. The fractures themselves cut through the outer ice in ways that show the region has not remained still for most of the moon's history. It has
Deep
been
beneath
shaped,
the hidden sea,
opened,
water-rock
and
reactions
modified
release
by
molecular
internal
hydrogen,
and orbital
a crucial
processes,
energy source.
rather than left only to the slow accumulation of impacts from space. This gives the South Pole a special role in understanding Enceladus. It is not just one region among many. It is the most concentrated expression of the moon's present-day exterior activity. Temperature measurements strengthen this view. The South Polar area is not warm in any Earth-like sense,
While Mars
but
offers
it is
clues to
measurably
ancient
warmer
life in
than
its
much of the
exposed
rest of the
basins.
surface. In planetary terms, that difference is significant. When a small icy moon displays a local concentration of heat in the same region where its
The
most
essential
unusual
distinction
fractures
is
are
clear.
found,
While
the
chemically
simplest
rich and protected,
conclusion
this
is that
remains
the
a world
fractures
that may
and the
support
heat
life.
belong to the same active system. The exact amount of heat and the details of how it is distributed have been refined over
The
time,
hydrothermal vents
but the
release
broad
plumes
picture
rich
is
in
secure.
hydrogen,
The
evidence that
South
makes
Polar
Enceladus
terrain
a
is
strong
an energy-rich
candidate for ocean
patch on an
habitability.
otherwise deeply frozen world. This concentration creates an important scientific problem. If tidal heating acts on the whole
While
moon,
Mars requires deep
why
drilling
is the
for past
strongest
traces,
outward
Enceladus
sign of
offers
activity
direct
so
access to a
localized?
subsurface ocean,
Several
making it a prime
explanations
candidate for
have been
present-day
studied,
life.
and they may work together rather than compete. The ice shell may be thinner in the South Polar region than elsewhere, making it easier for tidal stresses to
Enceladus
deform
may
the
matter
surface
more
there.
than Mars for present-day
The
life
mechanical
because it
properties of
appears
the
to
ice
combine
may
liquid
also
water,
vary from
key
place to place. Ice is not a single unchanging material. Its strength depends on temperature, grain size, impurities, and rate of deformation. Warmer ice tends to deform more readily, and once a region begins to focus strain and heat, that focus may help sustain itself. A slightly weaker area can become the place where future stress continues to gather. This does not mean the South Pole is simple. The tiger stripes are not motionless cuts in a rigid shell. Observations indicate that they open and close by small amounts as Enceladus moves through its orbit around Saturn. That behavior fits the wider picture of tidal forcing. As the moon flexes,
How a very small
the
moon
fractures
in a
respond.
giant planet system
They are
can still
therefore not
become
only
one of the
scars
most
of earlier
compelling
stress,
life
but
surge
active
targets.
boundaries that remain sensitive to the moon's changing position in its orbit. A fracture that repeatedly changes width is a structure in motion, even if the motion is subtle. It belongs to the living mechanics of the ice shell rather than to a completed event in the distant past.
Beneath
The surrounding
this icy
topography
shell,
also
Enceladus
suggests
hides a
repeated
global
modification.
ocean.
Ridges flank some of the main fractures, and the terrain between them has a texture that reflects extension, settling and resurfacing. These landforms are important because they show that the tiger stripes are not isolated cracks drawn across an otherwise ordinary plane. They organize the wider South Polar landscape. The whole region seems shaped around them,
Mars
as though the
offers
moon's
clearer
outer
skies
shell
for
has been
direct
reworked
inspection, but
repeatedly
the
along
subsurface
preferred
ocean of
lines of
Enceladus
weakness.
may hold the true
In this
promise
sense,
for
the
life.
fractures are both features and framework. They mark the places where the shell gives way, and they help define the architecture of the terrain itself.
The question is
Darkness
not which world
associated
is
with the
easier
tiger
to
stripes
explore,
should also be
but
understood
which one
carefully.
harbors the
The
conditions.
stripes are not dark because they are made of some fundamentally separate surface material in large quantity. Much of the surrounding moon is bright with water ice.
The comparison
and
isn't
the
between
dark
a dead
appearance of the
Mars and a
fractures
living
is
Enceladus,
largely a matter
but
of
between two
contrast,
astrobiological
texture,
prizes.
shadow, and the exposure of fresher or more complex structural zones within the icy crust. Their visual power comes from standing out against one of the brightest surfaces in the solar system. A line does not need to be black in an absolute sense to appear strikingly dark when set into brilliant ice. At this stage of the journey inward, the tiger stripes matter because they are the clearest openings in the outer shell as an active boundary. They show where the moon's geological energy is focused. They show that the south polar ice is not equally sealed everywhere. They show that Enceladus is not merely renewed in a broad and diffuse way, but organized around a few specific structures through which the stress of the orbit is translated into local deformation. In a quiet scientific sense, these fractures are the surface expression of a hidden system pressing upward. They make the South Pole different from the rest of the Moon, not by size alone, but by function. For the larger comparison with Mars, the South Polar fractures introduce a different kind of target. Mars offers ancient deltas, sediment layers, and mineral records of vanished surface water. Enceladus offers a frozen exterior marked by narrow active structures that remain tied to present-day energy.
These smooth, resurfaced
The value of
regions
the tiger
stand in
stripes
sharp
lies in
contrast
that
to the
present
ancient,
connection.
cratered foreground.
They are not simply relics to be
The
interpreted
northern
after the
regions of
fact.
Enceladus
They
reveal
are
a
active
stark contrast.
interfaces in the ice.
Ancient, heavily
Places where the
cratered
exterior visibly responds to processes still operating now. The outer shell of Enceladus is therefore not a featureless frozen lid. At the South Pole it is cut, warmed, and mechanically alive along a small set of extraordinary lines. Above the South Polar fractures, Enceladus does something rare among small icy worlds. It releases material
in
directly
orbital
into
resonance
space.
with Dione.
This escaping
Enceladus
material
undergoes
forms
powerful
towering
flexing.
plumes above the surface, rising from the region
The
of the
orbital
tiger
resonance
stripes
with
in
Dione
broad curtains
creates
and
intense
narrower
tidal heating
jets.
deep within Enceladus.
Against the black background beyond the moon, the plumes transform Enceladus from a bright frozen body into an active source of matter. The moon does not only bear signs of internal activity written on its surface, it physically sends part of that activity outward, where spacecraft can pass through it and measure it. The existence of these plumes
are the tiger
changes the
stripes,
scientific status of
active
Enceladus
fracture
in a
zones
fundamental
in
way.
the south polar terrain.
Many worlds may hide interesting internal environments, but most keep them sealed behind rock, ice, or dense atmosphere. Enceladus is unusual because material connected to its interior reaches open space. The plumes are therefore not merely a surface weather effect, and not simply a decorative spray above the pole. They are pathways of exchange. Matter leaves the moon, enters the space around Saturn, and becomes available to observation without the need to cut through kilometers of ice. For the search for life, this outward accessibility is one of the most important facts about Enceladus. The plumes are made of both water vapor and icy grains.
Saturn's E-ring
Some of the
is
escaping
unique,
material
a vast
is
torus
gas,
of icy particles
while some
replenished by the
freezes or
continuous
remains
eruption
as
of
tiny
Enceladus's
particles
south
that
pole.
scatter light. Sunlight and spacecraft imaging make the plumes visible, because these particles reflect light in the space above the South
This
Pole.
fly-through offers a rare
Their
chance
appearance
to
is
gather
delicate from
interior-related
afar,
material from an
but
ocean
the
world
process behind them
directly in
is
space.
energetic enough to lift material away from the moon's weak gravity. Enceladus is small, and that smallness matters here in a new way. A low escape speed means that material does not need the force required on a larger world to leave the surface and disperse into surrounding space. This escaping matter does not vanish into emptiness without consequence. A significant portion contributes to
This
Saturn's
active
broad
venting reveals
E-ring,
Enceladus's
the
south
diffuse
pole as a
ring through
tectonic
which
gateway.
Enceladus travels. In this sense, the moon is not only embedded in the ring, it helps maintain the ring. Tiny icy particles released from the south polar region spread outward and join the wider environment around Saturn. The local activity of one
This
small
stunning
moon
view highlights
therefore
the
shapes a
plume's
structure
water-dominated
visible on a
nature.
planetary scale.
Both the vapor and the ice
This
rings
relationship between moon and ring is another sign that Enceladus is an active participant in its system, rather than a passive object moving within it. The form of the plumes also reveals something important about the fractures below. They are not emitted equally from all parts of the moon. They are concentrated at the South Pole and tied closely to the Tiger Stripe region. This strengthens the conclusion that the fractures act as conduits through which material ascends and escapes. The plume pattern does not suggest a globally porous surface leaking everywhere in a weak and diffuse way. It suggests focused release through a small
These
number of
silica-rich
active
particles
pathways.
provide the strongest evidence
Enceladus
yet
is
of hydrothermal
selective in
activity.
where it opens. Observations over time indicate that the strength of the plume activity changes with the moon's orbital position. This modulation fits the broader tidal story already established at the scale of the whole moon and the fractures. As Enceladus
Cassini
moves
mission
around
revealed
Saturn
Enceladus
and the stress
possesses a
field
subsurface
shifts,
ocean,
the
indicated by
tiger
the
stripes
surprisingly
appear to
thin
respond, and the amount of escaping material changes as well. The plumes are therefore not independent of the moon's motion. They are part of the same dynamical system. Orbit, stress, fracture behavior, and release into space remain linked. This makes the plume not an isolated event, but a repeating expression of the moon's continuing interaction with Saturn. The scientific importance of this outward release becomes clearest when compared with more familiar targets such as Mars. Mars may preserve signs of ancient habitability in rocks, sediments, and
The
minerals,
plumes vent chemically
but
rich
any
samples
direct
from a hidden
sampling of
global
its most
ocean,
protected
making
environment
Enceladus
is
one of the
difficult.
clearest ocean world
The
candidates
surface
in the solar
today is
system.
exposed to
This cutaway
radiation,
reveals Enceladus'
oxidation,
hidden ocean,
cold,
a
and
rich source of
dryness.
dissolved materials.
If life
far
ever
beneath the
survives
icy
there
shell.
now, many researchers expect it
beneath
will be
the
most
ice of
likely in the
Enceladus,
subsurface,
we find not
beyond
just
easy
water,
reach.
but the ingredients
Enceladus
necessary for
presents a different
habitability.
challenge. Its promising environment, if one exists, is also hidden beneath the surface. Yet the moon appears to deliver samples upward and outward by itself. A spacecraft can fly through the plume and collect evidence from material already brought into space. This does not mean the sampling is complete or simple. Material changes as it rises and escapes. Some larger or heavier components may be underrepresented in the escaping
This
fraction.
equilibrium is central to
Some
habitability,
processes during
because
ascent
usable
can
energy
alter the
depends
state of
on
the
chemical
material before it
contrasts
reaches a
rather than
detector.
chemical sameness.
Scientists therefore remain careful about how directly plume measurements can be translated into a full picture of conditions below. The plumes are an opportunity, not a perfect mirror. Even so, the opportunity is extraordinary. They reduce one of the hardest barriers in planetary exploration. The ice shell does not remain a total wall when the moon itself vents matter through it. The plumes also influence mission design and scientific imagination. A world with an ocean hidden beneath ice would normally seem to require a lander, a drill, and an enormous technological effort before any direct test of chemistry could begin. Enceladus shifts that logic. A flyby spacecraft, if equipped with suitable instruments, can gather particles and vapor directly from the ejecta. This lowers the threshold for meaningful investigation, even though many technical difficulties remain. The Moon invites study in a way few other ocean worlds do. It does not expose its depths openly, but it releases traces of them into a region that machines can cross. At the scale of this section, everything remains outside the Moon. The focus is still on the plume as a visible and measurable region above the fractures, where
Deep
hidden
beneath the
activity
ice shell
becomes
lies a
external
global
matter.
ocean, where water
What
circulates
matters
through a
most
porous,
is not yet the
mineral-rich
detailed
core.
composition of that matter, but the simple fact of release itself. Enceladus is not fully sealed. The space around it
Deep
contains
beneath the
material
waves,
actively
water
supplied
permeates
from
the
the
rocky
Moon.
core through a vast
That material
circulation
can be
network.
seen,
This
tracked, sampled, and related to the changing stresses of the orbit. In the calm language of planetary science, this is one of the clearest reasons Enceladus may be such a powerful place to search for living conditions.
deep beneath the
The
hidden
Moon
sea,
sends evidence
water
outward.
rock reactions
It
release
turns
molecular
deep
hydrogen,
isolation into
a
partial
crucial
access.
energy source.
Once the plume is recognized as real and reachable, attention turns from the fact of escape to the character of the escaping material. The plume is not made of one simple substance alone. Cassini shows that the gas and grains rising above Enceladus contain a mixture of components, and that mixture is what gives the Moon its astrobiological importance. Most of the plume is water in
While
the form
Mars
of
offers
vapor,
clues
with
to
additional
ancient
water
life in its
frozen into
exposed
tiny ice
basins.
particles. This is the dominant fact of the composition. Enceladus is not venting dust in a dry sense, nor releasing only trace moisture from a
The
frozen
essential
crust.
distinction is clear.
It is sending out
While
matter
chemically
that is
rich and protected,
overwhelmingly
this
tied to
remains a
liquid
world that may
water and
support life.
water-derived ice. Alongside water, instruments detect other compounds in smaller amounts. Carbon
The
dioxide
hydrothermal
appears
vents
in the
release
gaseous
plumes rich
mixture.
in hydrogen,
Methane
evidence
is
that makes
present.
Enceladus a strong
Ammonia is
candidate for
present.
ocean habitability.
Molecular hydrogen is present. Salts are found in ice grains. Organic compounds are also detected, including
Mars
simple
requires deep drilling
carbon-bearing
for past
material
traces.
and evidence
Enceladus
for
offers
larger,
direct
more
access to a
complex
subsurface
organic
ocean,
material
making it a prime
associated
candidate
with
for
some of the
present-day
icy
life.
particles. None of these components, taken alone, proves the existence of life. Their importance lies elsewhere. Together they
Enceladus
show
may
that
matter
the
more
plume
than Mars
contains
for present-day
more than
life
water.
because it appears
It
to
carries a
combine liquid
chemically
water,
interesting
key
sample, one that includes several kinds of matter relevant to habitability, as that word is used in planetary science. The term organic is useful here, but it needs a plain meaning. In this scientific context, organic compounds are carbon-based molecules. They are common in the universe and do not by themselves indicate biology. They can be formed by non-living chemistry in many environments. On Enceladus, their presence matters because life as known on Earth depends on carbon chemistry, and because carbon-bearing molecules can take part in broader chemical pathways that matter for living systems. The plume, therefore, does not merely contain frozen
How a
water
very
from a
small
chemically
moon
empty
in a
source.
giant planet system
It includes
can still become
carbon-rich
one of the most
ingredients that make
compelling
the
life
material
search
more
targets.
interesting than plain ice. The salts found in plume particles are important in a different way. Salt-rich grains indicate that at least some of the material has interacted with liquid water that has been in contact with dissolved minerals. Pure surface frost alone would not be expected to carry the same
Beneath
signal.
this icy shell,
The presence of
Enceladus hides
sodium
a
and
global
potassium
ocean.
salts in particles supports the view that the expelled material is connected to a subsurface reservoir, rather than being produced only by shallow surface processes. Salt gives the plume a memory of liquid chemistry. It points toward water that has spent time in contact with rock or dissolved material, not merely water frozen in isolation.
Mars
The
offers
detection
clearer
of
skies for
molecular
direct
hydrogen
inspection,
adds another
but
layer.
the subsurface ocean of
Hydrogen
Enceladus
gas is
may hold the
chemically
true promise for
significant
life.
because it can serve as an energy source in some microbial ecosystems on Earth, especially in environments associated with water-rock reactions. Its
question
presence in
is
the
not
plume
which
does
world
not
is easier to
demonstrate that such
explore,
biology
but
exists
which one
on
harbors the
Enceladus.
conditions.
What it does show is that the moon may provide chemical imbalance, and chemical imbalance is one of the conditions that can allow metabolism.
The comparison
system
isn't
in
between a
complete
dead Mars
equilibrium
and a
offers
living
little
Enceladus,
useful
but
energy
between
for
two
life.
astrobiological
A
priors.
system that contains compounds able to react with one another under the right conditions offers more potential. Hydrogen therefore matters less as a dramatic molecule in itself, and more as a sign that Enceladus may not be chemically exhausted. Ammonia also deserves careful attention. It can help lower the freezing point of water, which is relevant on a moon where cold dominates the exterior. It is also a nitrogen-bearing compound, and nitrogen is a fundamental element in biological molecules on Earth. Again, caution is necessary. Ammonia in a plume is not evidence of living chemistry. It is one part of a broader inventory, but inventory matters. A habitable environment is not defined by one ingredient alone. It is judged by the combination of available matter, energy, and environmental stability. The plume begins to reveal such a combination in fragments. One of the most important developments in recent years concerns phosphorus. Analysis of Cassini data indicates that phosphorus, an essential element for life on Earth, is likely present in the ocean source of Enceladus and is represented in salt-rich ice grains ejected into space. This is scientifically
These
important
smooth,
because phosphorus
resurfaced
had long been
regions stand in
regarded as
sharp
one
contrast
possible
to the
limiting
ancient,
ingredient in
cratered
ocean
foreground.
worlds. It plays central
The
roles
northern
in Earth
regions of
biology,
Enceladus
especially
reveal a
in
stark
molecules involved in
contrast.
energy transfer,
Ancient,
cell
heavily cratered
structure, and genetic systems. The indication that phosphorus may be available on Enceladus reduces one major uncertainty in the Moon's habitability profile. It does not remove all uncertainty, but it strengthens the case that the plume is carrying evidence of a chemically rich system, rather than a narrow or impoverished one. There is also evidence for tiny silica-rich particles associated
In orbital
with the plume
resonance with
environment.
Dione,
These
Enceladus
particles
undergoes
matter
powerful
because silica
flexing.
can form under conditions involving hot water.
The
and
orbital
rock
resonance with
interaction.
Dione creates
Their
intense tidal
interpretation
heating
has
deep within
supported the
Enceladus.
idea that the
Keep-
source environment includes water that has encountered mineral material under active conditions. Even here, scientists remain measured. A particle does not tell the whole history of the Moon. The path from formation to ejection is complex, and measurements made during high-speed fly-throughs require careful modelling. Yet the overall pattern
These
remains
are the tiger
persuasive.
stripes.
The plume
Active
chemistry is
fracture
not
zones
random.
in the south polar
It is
terrain.
coherent in a way that suggests a wet, mineral-bearing, chemically active source. The plume is therefore valuable not just because it exists, but because it carries a layered sample. Water dominates. Salts indicate dissolved minerals. Organic compounds show carbon chemistry. Hydrogen points to available chemical energy. Ammonia adds further chemical relevance. Phosphorus strengthens the inventory of essential elements. Each detection has its own uncertainty, its own instrumental limits, and its own interpretive context. Scientists do not claim that every molecule is measured with equal completeness, nor that the full composition has already
Saturn's
been captured.
E-ring is unique,
Some
a vast
compounds
torus of
may
icy
be
particles
missed,
replenished by the
altered
continuous
during
eruption of
ejection,
Enceladus's
or
south
difficult
pole.
to separate from background effects. The plume is informative, but not exhaustive. Still, even with these
This
limits,
fly-through offers a
the
rare
chemical
chance to
picture is
gather
remarkable.
interior-related material from an
Enceladus does
ocean
not
world
merely leak
directly
water
in
into
space.
space. It releases material that looks increasingly like a sample from an environment where several key requirements for life can coexist. At this stage of the journey inward, that is enough. The plume composition does not prove biology. It does not even prove that all parts of the hidden system are equally suitable for life. What it does show is that the moon's outward breath carries a
active
set of
venting
ingredients
reveals
far richer
Enceladus's
than
south
early
pole as a
expectations
tectonic
for a
gateway.
small icy world in the outer solar system. The chemistry rising above the South Pole is not barren spray. It is a measured sign that Enceladus contains more internal promise than its cold, bright surface first suggests. Between the visible surface of
stunning view
Enceladus
highlights the
and
plume's
the deeper source of
water-dominated
its
nature.
escaping material
Both
lies
the
the
vapor
ice shell
and the ice
itself.
grains
This shell is not merely the surface seen from orbit. It is the larger frozen layer that forms the moon's outer body, extending downward from the bright exterior into colder and warmer ice that behaves differently with depth. It is both roof and wall. It defines the boundary between open space and the protected interior. At this stage in the journey inward, the shell matters because it explains how Enceladus can be harsh on the outside while still preserving a different environment below. Ice in planetary science is often imagined as something simple and brittle, but on a moon like Enceladus,
These
the
silica-rich
reality is more
particles provide the
complex.
strongest evidence yet
Water
of
ice
hydrothermal
changes its
activity.
behavior with temperature, pressure, grain structure, and time. Very cold ice near the surface can crack and hold fractures. Warmer ice at greater depth can slowly deform, bending and flowing over long periods rather than breaking suddenly.
The Cassini
The shell,
mission revealed
therefore, is not one
Enceladus
uniform
possesses
slab.
a subsurface ocean,
It is a layered
indicated by
mechanical
the
system.
surprisingly thin ice.
Its upper parts tend to preserve the sharp features of fractures, ridges, and crater walls, while deeper parts may yield more gradually under stress. This difference is important because it allows the shell to act at once as a rigid boundary and as a responsive one. Its thickness remains one of the key scientific uncertainties. Researchers do not claim a single exact value for the shell across the entire moon. Different models and measurements indicate that the shell is not equally thick everywhere. It appears to be thinner in the South Polar region, where activity is
plumes vent chemically
concentrated
rich
and
samples from a
thicker
hidden global
elsewhere.
ocean, making
That
Enceladus one of the
unevenness
clearest
helps
ocean
explain
world
why the
candidate
tiger
in the solar
stripes
system.
form where they do,
This cutaway
and
reveals
why the plume
Enceladus's hidden
escapes from a
ocean,
limited
a
area
rich
rather
source
than
of
from the
dissolved
whole
materials
body.
far beneath
A
the
thinner
icy
shell
shell.
is easier to deform, easier
Deep
to
beneath
fracture,
the ice of
and more
Enceladus,
likely to
we
allow
find
material
not just
to move
water,
upward through
but the
it.
ingredients
A
necessary
thicker
for
shell,
habitability.
by contrast, is more resistant and more sealing. The moon's outer frozen layer is therefore not only a barrier in the general sense, it is a barrier with geography. The shell performs a protective role that matters deeply for habitability. Space is not empty in a benign sense. It is a region of vacuum, radiation, charged particles, and constant exposure to micrometeoroid impacts. On the surface of Enceladus,
This equilibrium
there
is
is no
central to
thick
habitability
atmosphere to soften
because
this
usable
environment.
energy depends on
The
chemical
exterior is
contrasts
directly
rather than
exposed.
chemical sameness.
Any delicate chemistry at or near the surface is subject to damage and alteration by radiation and by extreme cold. The ice shell separates whatever lies beneath from that exposure. Even a modest thickness of ice can greatly reduce radiation penetration and buffer temperature change. A thick shell can preserve internal conditions over long spans of time by shutting out much of the instability of the surface environment. This protective function helps explain why Enceladus may be more favorable for life than Mars in one important sense. Mars has records of ancient water and sediment on its surface, but the surface today is dry, thinly shielded, and exposed to energetic radiation from space and from the sun. Any living system near the Martian surface would have to endure conditions that are punishing and variable. Enceladus, by contrast, places its potentially interesting environment beneath a frozen cover. The shell creates distance from direct exposure. In that sense, it acts less like a prison than like insulation. It blocks easy access, but it also blocks many of the destructive forces that would otherwise make long-term survival difficult. At the same time, the shell is not an ideal barrier in every respect.
Deep beneath the ice
What
shell
protects
lies a global ocean,
also
where water
isolates.
circulates through a porous,
If life-related
mineral-rich core.
chemistry exists below, the ice shell limits the exchange of that environment with the outside. It prevents simple observation. It reduces the possibility
Deep
of
beneath the
direct
waves,
imaging.
water
It
permeates
makes
the rocky core
exploration
through a
technically
vast
difficult,
circulation network.
because any mission that aims to reach the deeper liquid region would face the challenge of penetrating many kilometers of ice under alien conditions. The shell, therefore, creates a scientific tension. It preserves the possibility of a stable internal setting,
Deep beneath
but
the
it
hidden
also
sea,
hides that
water
setting
rock
from easy
reactions release
confirmation.
molecular hydrogen.
The shell
a
is
crucial
important
energy
not
source.
only for what it blocks, but for what it controls. It regulates the movement of heat from the interior toward the surface. Heat does not escape equally through all parts of the moon. The shell's thickness, structure, and fracture pattern influence where energy is trapped and where it is released. In this way, the shell becomes part of the active system rather than a passive cover
While
placed over
Mars
it.
offers clues
A
to
thinner or
ancient
more
life in its
fractured
exposed
region can
basins,
transmit heat and material more readily. A thicker, colder region can keep that heat in. The shell shapes the pattern of activity by deciding how the moon communicates
The essential
with space.
distinction is clear.
Pressure
While
is another
chemically
part of
rich
its
and
role.
protected, this
Beneath
remains
the
a world that may
significant
support
thickness
life.
of ice, liquid water can remain stable under conditions where it would otherwise freeze or boil away if directly exposed.
The hydrothermal
The
vents
shell
release
provides
plumes rich in
confinement.
hydrogen,
It
evidence that
allows
makes
deeper
Enceladus a
regions to
strong
exist under
candidate for
pressures
ocean
very
habitability.
different from those at the surface. This does not guarantee a particular temperature or chemistry, but it helps make such conditions
While Mars requires
possible.
deep drilling for past
A
traces,
covered
Enceladus
environment
offers
is
direct
physically
access to a
different from
subsurface
an
ocean,
exposed
making it a
one.
prime candidate for
On
present-day life.
Enceladus, the shell creates that covered environment by sustaining a closed mechanical and thermal boundary. Its internal structure also affects how material may move
Enceladus may
through
matter
it.
more than Mars for
Fractures
present-day
near the
life
South
because
Pole
it
show
appears
that
to
the
combine
shell is
liquid
not
water,
sealed in
heat,
an absolute sense. Yet it is not fully open either. Most of the moon remains closed, while certain zones appear capable of transmitting matter upward. This selective permeability is one of the shell's most important qualities. It is protective without being perfect. It keeps the interior from simply venting away, but it still allows exchange at limited sites. That balance may be one reason Enceladus is so scientifically valuable. A completely sealed shell would hide everything. A completely broken shell might not preserve stable internal conditions for long. Enceladus appears to occupy an intermediate state, where the barrier holds globally but opens locally. The
How a
ice shell
very
therefore
small moon
defines
in
the
a
moon
giant
in a
planet
deeper way
system
than the
can still
surface alone
become
can
one of
show.
the most compelling life
It is the
search
cold
targets.
architecture that separates exposure from shelter, noise from stability, and easy destruction from long-term persistence. It is rigid enough to maintain a world beneath it, and dynamic enough to respond to tides and fractures. For astrobiology,
Beneath this icy
that combination
shell,
is
Enceladus
important.
hides a global
Life as
ocean.
known on Earth depends not only on ingredients and energy, but on settings where conditions remain stable enough for chemistry to continue over time. The shell may provide exactly that kind of long-term enclosure. It does not prove that life is present. It does not reveal the full character of what lies below, but it makes the existence of a protected internal habitat
Mars offers
far
clearer
more
skies
plausible
for direct
than the
inspection,
bare
but
surface
the
of a
subsurface
frozen moon
ocean of
would
Enceladus
suggest.
may hold the true
On
promise for
Enceladus,
life.
the ice shell is not only an obstacle to exploration, it is one of the main reasons the moon remains compelling at all. Beneath the ice shell
The
of
question
Enceladus
is not
lies
which
the
world
region
is
that
easier to
changes the
explore,
moon from an active
which
icy
one
body
harbors
into
the
a world
conditions.
of direct astrobiological interest. The evidence indicates that this hidden region is not just a few isolated pockets of melt trapped within the ice.
The comparison isn't
It is
between a dead Mars
subsurface
and a living
ocean,
Enceladus,
a body
but
of
between
liquid
two
water beneath
astrobiological
the frozen
primes.
exterior. That conclusion takes time to emerge, because no spacecraft has drilled through the shell and seen the water directly. Instead, The ocean is inferred from several lines of evidence that fit together with unusual strength. The moon's shape, gravity, motion, plume material, and thermal behavior all point toward the same broad picture. Enceladus appears to contain a global ocean beneath its outer shell. The idea of a global ocean is important because it is more than a question of size. A small, local sea under the South Pole would still be scientifically interesting. But planet-wide or nearly planet-wide liquid layer has a different meaning. It suggests that Enceladus is structured as a shell of ice floating above a deeper body of water, with the liquid extending around most or all of the moon, rather than being confined to one active region. In such a case, the South Pole becomes not the location of the only water, but the location where a much larger internal water system most clearly communicates with the surface and space. One line of evidence comes from the moon's motion. Enceladus does not rotate in a perfectly rigid way. Careful observations of slight variations in its orientation, known as libration, indicate that the outer shell is able to move somewhat independently of the deeper interior.
To the ancient,
Libration,
cratered foreground.
in plain terms, is a
The
small
northern
rocking
regions of
motion
Enceladus
superimposed on
reveal a
regular
stark
rotation.
contrast.
If the
Ancient,
moon were frozen
heavily
solid
cratered
from surface to center, the measured amount of rocking would be hard to explain. A global liquid layer beneath the shell offers a natural explanation, because it allows the icy exterior to be partly decoupled from the rocky core below. The shell can then respond differently to gravitational forcing than a fully solid body would. Gravity data add another layer to the same conclusion.
In orbital
As
resonance with
Cassini flies
Dione,
past
Enceladus
Enceladus,
undergoes powerful
slight
flexing.
changes in the spacecraft's motion reveal how mass is
The
distributed
orbital resonance
inside
with
the moon.
Dione creates
Those
intense tidal
gravity
heating
measurements
deep within
indicate that the
Enceladus.
south polar region contains an excess of mass relative to what a simple solid ice model would predict, and that this excess is consistent with liquid water beneath the ice. When the gravity results are combined with the moon's shape and topography, the simplest interpretation is that Enceladus has a differentiated interior, meaning that it is arranged
These
in
are the
layers
tiger
rather
stripes,
than remaining a uniform
active
frozen
fracture
sphere.
zones in the
A
south polar
rocky
terrain.
interior lies beneath, and above that rocky region there is liquid water overlain by ice. The data do not support the picture of a fully frozen moon. The plume itself strengthens the case. Water vapor, ice grains, salts, and other compounds escaping from the south polar region are much easier to understand if the source includes a liquid reservoir beneath the shell. Some shallow processes in ice can produce vapor, but the combination of water, dissolved salts, and broader chemical complexity is most naturally explained by material that has resided in liquid form. This does not mean that every
plumes do
plume
not fall
particle
back to
rises
the
directly
surface.
from the deepest part of the ocean without
Saturn's
modification.
E-ring is unique.
The
A
transport
vast
path
torus
can
of
be
icy
complex,
particles replenished
yet
by the
the plume
continuous
remains
eruption
one
of
of the most
Enceladus's south
persuasive
pole.
outward signs that liquid water is present below the surface and connected, at least indirectly, to the fractures of the south
This
polar
fly-through
terrain.
offers a rare chance
The
to
ocean is
gather
also understood to be
interior-related material
salty.
from an ocean world
Salinity
directly
matters
in
because
space.
dissolved salts change the physical behavior of water. They affect freezing temperature, density, and the chemical character of the liquid. The salts inferred from plume particles indicate that the water is not a pure melt of isolated ice. It is an ocean that has interacted with mineral material and has carried dissolved components into solution. The word ocean here therefore carries
This
its
active
full
venting
planetary
reveals
meaning.
Enceladus's
It
south
refers
pole
not
as a
merely to
tectonic
liquid
gateway.
water, but to a stable, chemically active body of water with internal circulation and contact with other parts of the moon's interior system. Its temperature remains uncertain in detail, but its very existence means that somewhere beneath the ice, liquid
This stunning view
persists over
highlights
long
the plume's
spans despite the
water-dominated
severe
nature.
cold above.
Both the vapor
The
and the ice
water is not
grains
expected to be warm in the ordinary earthly sense across its full volume. Different parts of the ocean may have different temperatures depending on depth, circulation, and the distribution of internal heat. Still, the essential point remains simple. Enceladus contains a liquid environment under the ice, and that liquid has not frozen away despite the moon's small size and great distance from the sun. This fact alone gives Enceladus a very different status from most small icy bodies in the outer solar system. The ocean also changes the scale of the comparison with Mars. Mars is a world where ancient surface
These silica-rich
rivers,
particles
lakes,
provide the strongest
and perhaps
evidence
seas
yet of
once
hydrothermal
existed
activity.
under open sky. Enceladus is a world where liquid water appears to exist now, but under ice and out of sight. This difference matters more than size or nearness to the sun. The present liquid environment, even a hidden one,
The
may in
Cassini
some
mission
respects
revealed
offer a stronger
Enceladus
setting
possesses
for
a
life
subsurface
than an
ocean,
exposed
indicated
world
by the
whose wetter
surprisingly
age
thin
lies mostly in the past. The ocean of Enceladus is not easy to reach, and it is not directly visible, but it appears to be contemporary rather than historical. It belongs to the Moon as it is now. The ocean's global nature also implies continuity. A connected liquid layer allows the transfer of heat, dissolved material, and pressure around the Moon more effectively than a set of isolated pockets would. It permits the possibility of broad circulation rather than local stagnation. Even if that circulation is slow and incompletely
The plumes
understood,
vent chemically rich
the
samples from a
existence
hidden
of a
global
connected
ocean,
water body
making
matters.
Enceladus one of the
A
clearest
global
ocean
ocean
world
is a
candidates in the
system.
solar system.
It can
This
respond to
cutaway reveals
tides,
Enceladus's hidden
redistribute
ocean,
energy,
a
and
rich
maintain
source of
large-scale
dissolved
physical
materials far
relationships
beneath the
between
icy
shell, liquid, and deeper
Deep
interior.
beneath the ice of Enceladus,
This gives
we find
Enceladus
not
an
just
internal
water, but
coherence
the
that
ingredients
isolated melt
necessary for
zones would
habitability.
not provide. Scientists remain careful in how they state the certainty. No one has directly entered the ocean. Its exact depth, thickness, and regional variation are still under study. The shape of the ice-water boundary may differ from place to place. Some models emphasize local differences in shell thickness or ocean structure. But the broad consensus is clear. Enceladus is best understood as an
This
ocean
equilibrium
world.
is central to
The
habitability
phrase is not
because
poetic.
usable energy depends
It is
on chemical
descriptive.
contrasts rather than
Beneath the
chemical
bright and
sameness.
bitterly cold shell lies a global liquid body that transforms the Moon from a frozen curiosity into one of the most compelling environments in the solar system for habitability studies. The hidden water is not a minor detail beneath the ice. It is the central interior region around which the scientific importance of Enceladus now turns. Within the hidden ocean of Enceladus, habitability depends not only on the presence of liquid water, but also on what is dissolved, suspended, or chemically available within that water. Water alone is not enough for life as it is known on Earth. Living systems require matter that can be built into cells, membranes, proteins, and genetic molecules. For that reason, the question inside the ocean becomes more specific. It is no longer only whether liquid exists, it is whether the ocean contains a useful inventory of elements and compounds that biology could draw upon if the other conditions were also suitable. Scientists often describe the essential elemental set for Earth life as carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. This is not a magical list, and it does not mean that all possible life everywhere must follow
Deep
exactly
beneath
the
the
same
ice shell
chemical
lies
pattern.
a global ocean,
It is
where
simply
water
the best
circulates
guide
through a
available
porous,
because it
mineral-rich
describes the
core.
chemistry common to all known biology on Earth, on Enceladus. The evidence now indicates that several of these key ingredients are present or very
Deep beneath the
likely
waves,
present in the ocean
water
source
permeates the rocky
sampled through
core
the
through a
plume.
vast circulation
That makes the
network.
Moon scientifically important. It is not a case of one promising ingredient found in isolation. It is increasingly a case of a broad chemical inventory emerging from the data. Water itself already provides hydrogen and oxygen,
Deep
and
beneath
it
the hidden
dominates
sea,
the ocean environment.
water-rock reactions
But
release
in a
molecular
habitability
hydrogen,
sense,
a crucial
those
energy
elements
source.
matter not just because they are part of the solvent. They also help shape the chemical setting in which other compounds dissolve, react, and move. A water ocean is valuable because it allows chemistry to proceed in an ordered, mobile way. Molecules can be transported, ions can remain in solution, and interactions between rock-dissolved salts and carbon-bearing
While Mars
compounds can
offers
continue
clues
over
to
long
ancient life
spans.
in its exposed
The water of
basins,
Enceladus is therefore not just background material. It is the medium that makes the rest of the inventory meaningful. Carbon is one of the strongest parts of that inventory.
The essential
Carbon-bearing
distinction is
compounds
clear.
have been
While
detected in the
chemically rich
plume,
and protected,
including
this
simple
remains a world
organics
that may
and
support life.
evidence for more complex organic material associated with ice grains. In plain terms, this means the ocean source of
hydrothermal
Enceladus
vents
does
release
not appear
plumes rich
chemically
in
empty
hydrogen,
or
evidence that
limited
makes
to water and
Enceladus a
salts
strong
alone.
candidate for ocean
It includes
habitability.
compounds built around carbon, the same element that gives flexibility and complexity to organic chemistry on Earth.
While Mars
Carbon is
requires deep
especially
drilling for
important
past
because
traces,
it can form
Enceladus
long
offers direct
chains,
access to a
rings,
subsurface ocean,
and
making
many
it a prime
different kinds
candidate
of
for
stable
present-day life.
structures. That versatility is one reason life on Earth depends on it so heavily. On Enceladus, the presence of carbon-bearing material does not
Enceladus
imply
may matter
life.
more than Mars for
But
present-day
it does
life
show
because
that
it
one of
appears to
biology's
combine
most
liquid
useful
water,
raw
key
materials is available. Hydrogen is also present, and in more than one sense, it is part of water itself. But measurements also indicate molecular hydrogen in the material released from Enceladus. In this section, the importance of hydrogen is still mainly as an ingredient rather than as an energy source. It is a fundamental part of many biological molecules and of many reactions involving carbon. A world that contains abundant water and additional hydrogen-bearing compounds provides a chemically rich setting compared with one that has only dry mineral surfaces. Hydrogen helps make the ocean of Enceladus an environment where more elaborate chemistry could, in
How
principle,
a very small
occur.
moon in a giant planet
Nitrogen
system
appears in
can
the
still
inventory
become
as
one
well,
of the most compelling
most
life
clearly
search
through
targets.
ammonia and related nitrogen-bearing material. Nitrogen is central in Earth biology because it is part of amino acids, proteins, and the bases used in genetic molecules. Its behavior in an ocean also matters physically, because ammonia can affect freezing
beneath
conditions
this
and
icy
chemical
shell,
balance.
Enceladus
On
hides a
Enceladus,
global ocean.
the evidence for nitrogen-bearing compounds strengthens the case that the ocean is not lacking one of the major ingredients used by life on Earth. It suggests that the liquid environment contains more than the simplest possible chemistry. Phosphorus has become one of the most important parts of the Enceladus story. For many years, it's often treated as a possible weakness in ocean worlds, because
Mars
phosphorus
offers
can be
clearer
difficult to
skies for
dissolve
direct
and keep
inspection,
available in
but the
water.
subsurface ocean
On
of
Earth, it is
Enceladus may
essential
hold
to
the true
biology.
promise for life.
It is part of molecules that store and transfer energy, part of cell membranes, and part of the backbone of deoxyribonucleic acid and
The question is
ribonucleic
not which
acid.
world is easier
If an
to
ocean
explore,
world were poor in
but which
available
one harbors
phosphorus,
the conditions
that shortage could place real limits on the development or productivity of Earth-like life. For Enceladus, this uncertainty has eased
The
considerably.
comparison isn't between a dead Mars and
Analyses
a
of
living
Cassini
Enceladus,
data
but between
indicate
two
that phosphates are
astrobiological
present in
prizes.
salt-rich ice grains ejected from the Moon, and models suggest that phosphorus may be abundant in the ocean, perhaps at concentrations greater than those typical of Earth's oceans. That result matters because it changes the picture from minimal habitability to richer habitability. Enceladus is not merely a place where some ingredients may scrape by in trace amounts. It may be a place where at least one previously uncertain ingredient is readily available. Researchers link this possibility to the likely chemistry of the ocean, which appears to be alkaline and rich in dissolved carbonates. In such a soda-rich water system, phosphorus may remain more available in solution than it often does in ordinary terrestrial seawater. This does not mean the ocean is friendly in every biological sense, or that all forms of Earth life would thrive there. It means only that one major elemental concern now seems less severe than once thought. Sulfur is the least secure part of the familiar biological set in the case of Enceladus. Some studies have considered sulfur-bearing compounds plausible or possible in the ocean system, especially through water-rock interaction in the deeper interior, but sulfur is not as firmly established in the outwardly sampled material as carbon, hydrogen,
These smooth,
nitrogen,
resurfaced regions
oxygen,
stand in sharp
and
contrast
phosphorus.
to the ancient,
This is a
cratered
good place
foreground.
for scientific caution.
The
The
northern
overall
regions of
habitability case for
Enceladus reveal a
Enceladus is
stark
strong without
contrast.
pretending that every
Ancient,
component is
heavily
equally well
cratered
constrained. The ocean appears chemically rich, but not every detail is settled to the same degree. Taken together, the picture is striking. The ocean of Enceladus seems to contain liquid water and access to the elemental framework used by life on Earth, including strong evidence for carbon, hydrogen, nitrogen, oxygen, and phosphorus, with sulfur less certain
In orbital
but still
resonance with
plausible.
Dione,
That
Enceladus
combination
undergoes
matters
powerful
because life is
flexing.
not built from abstract habitability. It
The
is
orbital
built
resonance
from
with
matter.
Dione
A
creates
promising
intense tidal
world
heating
must
deep
offer
within
real
Enceladus.
ingredients in real solution. Enceladus increasingly appears to do that. At this level of the inward journey, the ocean is best understood as a chemically stocked environment rather than a sterile reservoir of water. It contains dissolved salts, carbon-bearing compounds, nitrogen-bearing compounds, and now strong evidence for
these
accessible
are the tiger
phosphorus.
stripes,
This does not
active
demonstrate
fracture
that
zones
biology has
in the
emerged
south
there,
polar terrain.
and it does not tell how complex the chemistry becomes over time, but it does establish something very important. The water beneath the ice is not empty water. It is a liquid world with many of the ingredients that any serious search for life would hope to find. A liquid ocean with useful ingredients is still not enough to make an environment biologically promising. For life as it is known on Earth, chemistry must do more than exist. It must remain out of balance in a productive way. This is why scientists speak not only of water and elements, but also of energy sources. In a living system, energy is needed to build, repair, move, and sustain
Saturn's
order
E-ring is
against
unique,
the natural
a vast
tendency
torus of
toward
icy
chemical
particles
settling.
replenished by the
An
continuous
ocean
eruption
that
of
has all
Enceladus'
the right
south pole.
ingredients but no continuing source of usable energy would be chemically quiet. It might preserve matter, but it would offer little work
This
for
fly-through
biology
offers
to
a
do.
rare chance to gather
key idea here is
interior-related
chemical
material from an ocean
disequilibrium.
world
The term
directly in
sounds
space.
technical, but its meaning is simple. Disequilibrium means an imbalance between substances that could react with one another and release useful energy. A completely balanced system has little left to give. A system with contrast, with molecules that can still combine, exchange electrons, or transform into lower energy states, contains opportunity. On Earth,
This active venting
life
reveals
depends on such
Enceladus' south
opportunity
pole as a
everywhere.
tectonic gateway.
Plants use sunlight to maintain it near the surface. Microbes in dark environments use chemical gradients instead. They feed on differences between compounds. The same logic applies when Enceladus is considered as a possible habitat. Inside the ocean of
This stunning
Enceladus,
view highlights the
sunlight
plume's
is absent.
water-dominated nature.
No ordinary
Both the
surface
vapor and the ice
photosynthesis
grains
can operate in a hidden sea beneath a thick ice shell. Any life there, if it exists, would need to rely on chemistry rather than direct solar energy. This makes the ocean's internal chemical imbalance especially important. The question becomes whether the water contains pairs of substances that can interact in ways living systems might exploit. Cassini observations suggest that the answer may be yes. The detection of molecular hydrogen in the plume is one of the strongest reasons for that conclusion. Hydrogen matters because it is an energy-rich molecule in the right context. On Earth, many
These
microbes use
silica-rich
hydrogen
particles
as a
provide
fuel.
the strongest
They
evidence yet
combine
of
it with other
hydrothermal activity.
compounds and gain metabolic energy from the reaction. In Enceladus, hydrogen does not appear as a trivial trace in an otherwise inert ocean. Its presence suggests that the Moon is producing reduced chemical material, meaning matter that still holds energy in a form
The
that can be
Cassini
released
mission
through
revealed
reaction.
Enceladus possesses a
When
subsurface
hydrogen
ocean,
coexists with
indicated by the
compounds such as
surprisingly
carbon
thin
dioxide, methane, dissolved carbon species, or other oxidized material, the ocean is not chemically flat. It contains contrast. That contrast is the basis of potential metabolism. The ocean therefore seems important not just because it has the ingredients of life, but because it may also maintain the conditions that keep those ingredients active rather than dormant. A long-lived ocean can circulate, mix, dissolve minerals, and transport material. If the water were perfectly uniform and fully
The
settled
plumes
into
vent
chemical
chemically rich
balance,
samples from a hidden
habitability
global
would be
ocean,
weaker.
making Enceladus
But
one of the
Enceladus
clearest ocean
appears
world
to be an active
candidates in the
system.
solar system.
Its
This cutaway
plume chemistry
reveals
and
Enceladus's
broader
hidden
geophysical
ocean,
context
a rich
suggests that
source
the
of
ocean is
dissolved
supplied with
materials
fresh
far beneath
chemical
the icy
inputs over
shell.
time. In that case,
Deep beneath
the
the
ocean
ice
is
of
not simply a
Enceladus,
sealed
we find
reservoir
not just
of ancient
water,
water.
but the ingredients
It is a
necessary for
dynamic
habitability.
environment where useful imbalances may continue to arise. One useful comparison comes from dark ecosystems on Earth. In deep regions far from sunlight, some microbial communities live by chemosynthesis, a term for building biological matter using chemical energy rather than light. They survive because water, rock, and dissolved compounds create gradients that metabolism can use. Enceladus does not need to be
This
identical to
equilibrium
Earth
is
for this
central to
comparison to
habitability,
matter.
because usable energy
significance
depends
lies
on
in the
chemical
principle.
contrasts rather
Life
than
does
chemical
not
sameness.
require sunlight if another dependable energy path exists. A hidden ocean can remain biologically interesting when chemistry continues to supply fuel. The chemistry of Enceladus seems especially suggestive because the ocean is thought to be alkaline, rich in carbon-bearing compounds, and connected to internal processes that continue today. Alkaline here means that the water is likely more basic than neutral, with a chemistry shaped by dissolved carbonates and interaction with mineral material. Such water can influence which compounds remain dissolved and which reactions are favoured. It also affects how readily important elements, including phosphorus, may stay available in solution. These features do not prove that the ocean is energetically abundant in every part. They do suggest, however, that the water is not chemically inert. It remains a working environment rather than a static one. Scientists are careful when describing how much energy may actually be available. Measurements from plume material offer evidence, not a complete census of the whole ocean. The amount of hydrogen produced, the rate at which it is replenished, and the degree to which it meets or mixes with suitable reaction partners all remain subjects of modelling and interpretation.
Deep beneath
The ocean
ice
may
shell
not be
lies a
equally
global ocean,
favourable
where
everywhere.
water circulates
Some
through a
regions
porous,
may be more
mineral-rich
energy
core.
rich than others. Some gradients may be local, transient, or dependent on circulation patterns that are not yet well constrained.
Deep
These
beneath the
uncertainties
waves,
matter,
water permeates
but
the
they
rocky
do not
core
erase
through
the
a
broader
vast
conclusion.
circulation network.
Enceladus appears to possess more than a passive water inventory. It appears to possess chemically usable imbalance. This distinction is important for the comparison with Mars. Mars preserves strong evidence of past water and past habitable
Deep
settings,
beneath the hidden sea,
but the most
water-rock
accessible
reactions
environments
release
on present-day
molecular
Mars
hydrogen,
are dry,
a crucial
cold,
energy source.
oxidizing, and exposed. Potential modern life there, if any exists, would most likely require protected subsurface niches that are difficult to sample directly. Enceladus presents the opposite pattern. Its promising environment is also hidden, but that hidden environment seems to include not only liquid water and ingredients, but
While
ongoing
Mars
chemical
offers
energy.
clues to ancient
The
life in
Moon
its
may
exposed
therefore
Earth
offer a more
basins.
active present-day habitat, even though it is smaller, darker, and farther from the Sun. At the level of the ocean itself, the
The essential
conclusion remains
distinction is
measured.
clear. While
No
chemically rich
instrument
and
has yet
protected,
observed
this remains a
metabolism
world
on
that may support
Enceladus.
life.
No detected molecule can be claimed as a biosignature. The ocean's total energy budget remains uncertain
The
in
hydrothermal
detail.
vents release
Yet
plumes
the
rich
essential
in
idea
hydrogen,
has become much
evidence that
stronger
makes
than it once
Enceladus a
was.
strong candidate
The
for
water
ocean
beneath the
habitability.
ice does not seem chemically exhausted. It seems to hold the kind of disequilibrium that life can use. In astrobiology,
While Mars
that is a
requires deep drilling for
profound
past
shift.
traces,
The
Enceladus
world
offers
moves
direct
from
access
being
to a
merely
subsurface
wet to
ocean,
being
making it a prime
energetically
candidate for
habitable.
present-day life.
This is why Enceladus has become so compelling. Water gives chemistry a home. Ingredients give chemistry material. Disequilibrium
Enceladus may
gives
matter more
chemistry
than
work
Mars
to
for
do.
present-day life.
In the
because it
hidden
appears
ocean
to
of
combine liquid
Enceladus,
water,
all three
clean
now appear to be present in some meaningful degree. The case is not complete, and it is not final. But it is enough to change the search for life from a search for ancient traces alone into a search for an environment that may still be chemically alive in the present. At the bottom of the hidden ocean of Enceladus lies the seafloor, the place where liquid water meets the rocky interior. This boundary is one of the most important environments on the Moon because it joins three things that habitability requires: water, mineral matter, and a local source of heat. On Earth, places where heated water rises through the seafloor are called hydrothermal systems. The word
how a very
hydrothermal simply
small moon
means hot
in a
water.
giant planet system can
These
still
systems
become
are
one of the
important
most
because they
compelling
turn the
life
ocean
search
floor
targets.
from a passive boundary into an active chemical environment. On Enceladus, the evidence suggests that something broadly similar may exist at the base of the ocean. The strongest signs come indirectly, through material that eventually reaches space. Tiny silica
Beneath this
particles
icy
detected
shell,
by Cassini
Enceladus
are one
hides a
such
global
sign.
ocean.
Silica is a common mineral substance built from silicon and oxygen. In the context of Enceladus, these particles are important because their size and composition are consistent with formation in hot water that later cools and precipitates mineral grains. Laboratory work and modelling indicate that such particles can form where water interacts with rock at
Mars
elevated
offers clearer
temperatures,
skies for
then are
direct
carried
inspection,
upward through
but
the ocean
subsurface
and
ocean of
eventually
Enceladus
trapped
may
in
hold the
icy
true promise
grains
for life.
released from the Moon. This does not provide a photograph of the seafloor. It provides a chemical trace, a small mineral witness to conditions below.
The question is not
The
which world
temperatures
is easier
implied
to
by those
explore,
particles are not
but
temperatures
which
for the
one
whole
harbors the
ocean.
conditions.
They refer instead to localized conditions near the water-rock boundary. The ocean as a whole may remain cold by terrestrial standards, but
The comparison isn't
hydrothermal
between a
activity
dead
depends
Mars and
on
a living
contrast.
Anceladus, but between
The
two
seafloor system
astrobiological
can
priors.
contain warm or hot regions embedded within a much colder surrounding ocean. That contrast is exactly what makes such places so chemically interesting. Where heated water rises through cooler water, minerals dissolve, precipitate, and circulate. New gradients form. Fresh compounds enter solution. Energy remains available in a concentrated way. On Enceladus, the inferred seafloor activity appears important not because it makes the entire ocean warm, but because it creates local environments where chemistry becomes especially active. Molecular hydrogen supports the same picture from another angle. Hydrogen in the plume is best explained by ongoing reactions between water and rock in the interior, reactions that are often associated with hydrothermal settings. On Earth, similar processes occur when water moves through certain kinds of mineral-rich rock and alters them chemically. One outcome can be the release of hydrogen gas. In a hidden ocean, hydrogen does not simply add one more ingredient. It marks the possibility that warm water continues to react with seafloor materials in the present rather than in some distant past. The hydrothermal system is therefore not merely a warm spot. It is a working interface where fresh
These
chemical
smooth,
energy is
resurfaced
generated.
regions stand in
This
stark
matters because a
contrast to the
seafloor
ancient, cratered
hydrothermal
foreground.
environment can do more than mix minerals
The
into
northern
water.
regions of
It
Enceladus
can sustain
reveal a stark
disequilibrium at the
contrast.
place where it is most useful.
Ancient, heavily
Water
cratered
rising from heated rock can carry reduced compounds, dissolved ions, and fine mineral particles into the surrounding ocean. Cooler water can circulate back downward, allowing exchange rather than stagnation. The result is not simple heating, but chemical cycling. The seafloor becomes a zone of renewal, continuously feeding the ocean with new material and new
In orbital
gradients.
resonance with Dione,
In astrobiological
Enceladus
terms,
undergoes powerful
this is
flexing.
far more valuable than an ocean that remains chemically static.
The orbital resonance with
On Earth,
Dione creates intense tidal
hydrothermal
heating deep
seafloor
within
systems
Enceladus.
support microbial ecosystems that do not depend on sunlight. Life there uses chemical energy released by reactions among water, rock, and dissolved compounds. Enceladus is not assumed to duplicate Earth in detail, and the evidence does not justify such certainty. Still, the comparison is scientifically useful because it shows that dark ocean floors
These are
can
the
be
tiger
biologically
stripes,
productive
active
if they offer the right
fracture zones
conditions.
in the south polar
Sunlight
terrain.
does not reach the Enceladus ocean, but a hydrothermal seafloor would provide another path by which chemistry could remain active enough to matter for life. The physical setting is also favourable in a quiet way. A seafloor lies beneath the shielding ice shell and beneath the bulk of the ocean water. That depth protects it from the radiation and instability of the surface. It is an interior environment, buffered and enclosed. If life prefers persistence over exposure, a hydrothermal seafloor is one of the most stable places where it could potentially gain a foothold. Stability does not mean uniformity. Hydrothermal settings are defined by contrasts in temperature and
Saturn's
chemistry,
E-ring is unique,
but those
a vast
contrasts
torus
occur
of icy
within a
particles
larger
replenished
protected
by the
environment
continuous eruption
rather
of
than under open
Enceladus's south
sky.
pole.
The mineral character of the seafloor is part of the attraction. When water interacts with rock over long periods, it can dissolve some
This fly-through
components,
offers a rare
alter
chance
others,
to gather
and create fresh
interior-related
surfaces
material
for
from an
reaction.
ocean world directly
Fine
in
mineral
space.
grains can form. Dissolved salts can accumulate in the ocean. Compounds that are difficult to produce in a purely icy setting can emerge more naturally in a rock-water system. This is why the seafloor matters more than the ocean alone. Water without rock is less chemically versatile. Rock without water is dry chemistry. Together, especially under hydrothermal
This active
conditions,
venting reveals
they
Enceladus'
create an
south pole
environment
as a
capable of
tectonic gateway.
complexity. Scientists remain careful in describing the exact form of the hydrothermal activity. The evidence supports active water-rock interaction and seafloor heating, but it does not yet reveal whether the seafloor contains chimney-like vents,
This stunning
exactly
view
like
highlights
those
the
on
plume's
Earth.
water-dominated
broad,
nature.
warm
Both the
seepage
vapor and the
zones,
ice grains.
scattered reaction sites, or some combination of these. The word hydrothermal therefore should be understood in its general scientific sense, not as a promise that Enceladus reproduces every visible feature of terrestrial black smokers or white smokers. The basic principle is what matters. Hot, mineral-bearing water appears to interact with the ocean at the floor, and that interaction is enough to make the region highly significant. This is one of the clearest reasons Enceladus may be a better place for life than Mars. Mars preserves evidence of ancient lakes, rivers, and habitable surface
These silica-rich
environments,
particles provide
but
the
the planet's
strongest
present
evidence yet of
surface is
hydrothermal
exposed
activity
and dry. Enceladus offers something less familiar, yet perhaps more favourable in the present tense: a protected ocean with probable hydrothermal activity at its base. That kind of setting combines water, chemical gradients, dissolved
The
minerals,
Cassini mission
and
revealed
local
Enceladus
heat in a
possesses
single
a
region.
subsurface ocean,
It is not
indicated by
open
the
and
surprisingly
easy to
thin
inspect, but it may be continuously habitable in a way that much of Mars no longer is. At the ocean floor of Enceladus, the moon becomes more than an icy shell around a hidden sea. It becomes a place where heat touches water, where minerals enter motion, and where chemistry is renewed from below. The seafloor is not visible, but it is increasingly legible through the traces it sends upward. In those traces, scientists see one of the most plausible dark habitats in the solar system, not a surface oasis, but a submerged boundary where liquid
The
water
plumes
and
vent
warm
chemically
rock
rich
meet
samples from a hidden
and
global
keep the ocean
making
chemically
Enceladus one of the
alive.
clearest ocean world candidates
Below
in the
the
solar
ocean
system.
floor of
This
Enceladus
cutaway
lies the
reveals
deepest
Enceladus's
active
hidden
region
ocean,
yet
a
considered.
rich source of
the
dissolved
rocky
materials
core.
far beneath the
This is
icy
not
shell.
a metallic center like that of a large
Deep beneath
terrestrial
the ice of
planet,
Enceladus,
and it
we
is
find
not
not just
understood as
water,
a single
but the
hard
ingredients
stone
necessary
sphere
for
sealed off
habitability.
from water. The evidence instead suggests a porous, rocky interior, a body of mineral material through which ocean water can move. Porous means full of tiny spaces, channels, and connected gaps. In such a structure, water does not remain only above the rock. It can seep downward into the core, circulate through it, warm there, react there, and return carrying chemical changes with it.
This equilibrium is
This
central
is
to
why the
habitability
core matters so
because
much.
usable energy depends
It is
on
not
chemical
merely the
contrasts
foundation
rather
beneath
than
the
chemical
ocean.
sameness.
It may be the engine that keeps the ocean chemically productive over time. A porous core greatly increases the area where water and rock can meet. This point is essential. Habitability does not depend only on having water in contact with a flat seafloor surface. If water can penetrate deep into the rocky interior, then the total contact area between liquid and minerals becomes much larger. A larger contact area means more opportunities for reactions, more dissolution of useful compounds, and more ways for heat to be transferred into circulating water. In practical terms, a fractured and permeable core is far more chemically interesting than a smooth, isolated boundary would be. It turns the moon's interior into an interacting volume rather than a simple layered stack. The gravitational forcing that flexes the whole moon likely also affects the rocky interior. Tidal stress does not stop at the ocean or the ice shell. It reaches downward and mechanically works the core as well. That repeated stressing can produce heat in the rock, especially if the interior contains a deformable framework of mineral grains and pore spaces, rather than a perfectly rigid mass. Over long spans of time, this means the core can remain an active place where water
Deep
enters
beneath the
cool,
ice shell lies
is
a
warmed
global
by
ocean,
contact
where
with
water
tidally
circulates
heated
through a
material,
porous, mineral-rich
and rises
core.
again because warmer fluid becomes more buoyant. A circulation system of this kind would keep the core from becoming chemically stagnant. One of the key
Deep
processes
beneath the
thought
waves,
to occur in
water
such settings
permeates
is
the rocky core through a
serpentinization.
vast circulation
The word
network.
refers to a set of
This-
water-rock reactions involving certain minerals that are rich in magnesium and iron. When water interacts with those minerals under suitable conditions, the minerals change their structure and chemistry. New mineral phases form.
Deep
Hydrogen
beneath the
can be
hidden sea,
released,
water
and heat
rock
may also be
reactions release
produced or
molecular
redistributed.
hydrogen, a crucial
The details are
energy
complex,
source.
but the main idea is simple. Water changes the rock, and the rock changes the water. Each pass through the core can therefore alter the chemistry of the ocean above. Serpentinization is important on Enceladus, not because it is a dramatic word, but because it offers a realistic mechanism for generating hydrogen and maintaining chemical imbalance in a dark ocean world.
While
This
Mars
kind of
offers
reaction
clues
makes
to
the
ancient
core
life
more
in its
than a heat
exposed
source.
basins,
It makes it a chemical processor. Water that enters the core does not merely warm and return unchanged. It can pick up dissolved ions,
The
interact with
essential
fresh
distinction
mineral
is clear.
surfaces,
While chemically
and
rich
emerge
and
with a
protected,
different chemical
this remains a
character from
world
the
that may
water that
support
went
life.
in. This is how a rocky interior can shape the habitability of an entire ocean. The core determines not only how
The
much heat
hydrothermal
rises
vents
upward,
release plumes
but
rich
also
in
what kinds
hydrogen,
of compounds
evidence
the
that makes
ocean
Enceladus
receives,
a strong
and how
candidate for ocean
continuously those
habitability.
compounds are renewed. The evidence for this picture remains indirect but coherent. Gravity measurements support the idea of a
While Mars requires
low-density,
deep drilling for
porous
past traces,
rocky
Enceladus
interior
offers
rather
direct
than a
access to a
compact solid
subsurface
rock
ocean,
center.
making it a prime candidate
Plume
for present-day
chemistry
life.
indicates water-rock interaction, especially through hydrogen and mineral particles. Models of internal heating show that a porous core
Enceladus
worked
may
by
matter more
tides
than Mars
can
for
sustain
present-day life
significant
because it
energy
appears to
release
combine
over
liquid
very
water,
long
key
spans of time. Scientists remain careful about the details. They do not claim to know the exact mineral makeup of every part of the core, nor the full geometry of pore spaces, nor the precise pace of circulation throughout the interior. But the broad structure is now persuasive. Enceladus likely contains a core that is open enough to water to make deep geochemistry a continuing process. This continuing process matters because habitability is not a momentary quality. A world may briefly have liquid water after an impact or during a short heating episode, yet still fail to offer the long-lived stability that biology would likely need. The rocky core of Enceladus
How a
suggests
very
something
small
different.
moon in a giant
If
planet
tidal
system
heating and
can
water
still become
circulation
one of the most
continue across
compelling
large
life search
spans of
targets.
time, then the moon's internal chemistry is not a short event, it is sustained. That long duration is one of the strongest advantages Enceladus may hold over Mars in the present tense. Mars preserves ancient evidence of habitability, but many of its most favourable surface conditions belong to the distant past. The core of Enceladus may still be working now. The core also helps explain why the ocean appears chemically rich rather than thinly flavoured by trace contact. A small amount of interaction at one boundary might not be enough to account for the detected salts, hydrogen, silica, and broader indications of alkaline water chemistry. A porous
Mars
interior
offers
with
clearer
large
skies for
reactive
direct
surface area
inspection,
offers a
but
much
the
more
subsurface
effective
ocean of
source.
Enceladus may hold the
Water
true
moving
promise
through
for
rock
life.
can continually dissolve, alter, and transport material. Over time, the ocean above becomes the chemical expression of the core below.
The question is not
In
which
this
world
sense,
is easier to
the ocean's
explore,
inventory is
but
partly a
which one
message written
harbors
by
the
the rock.
conditions.
There is also a deeper astrobiological significance. Many ideas about the origin of life on Earth place special weight on environments
comparison
where
isn't
water
between a
and
dead
minerals
Mars and a
interact
living Enceladus,
continuously,
but between two
where natural
astrobiological
gradients
priors.
form, and where small compartments or surfaces can help organize chemistry. A porous rocky core potentially offers all of these in some form. Tiny spaces in rock can create local chemical differences. Mineral surfaces can help reactions proceed. Warm fluid movement can bring fresh compounds into contact again and again. Enceladus is not assumed to repeat Earth's exact history, but it may provide the same broad ingredients for prebiotic chemistry, meaning chemistry that comes before biology. At the same time, uncertainty remains part of the honest picture. Scientists do not know whether the core reacts uniformly or only in certain zones. They do not know whether the most productive reactions are concentrated near the top of the core, deep within it, or in regions where tidal stresses are strongest. They do not know how the core has changed over the full lifetime of the moon, or whether its permeability has increased or decreased with time. These unknowns are real, yet they do not weaken the basic conclusion. The core is not best understood as an inert weight beneath the ocean. It is best understood as an active participant in the moon's internal system. At the deepest level of Enceladus, then,
These smooth,
the search for life
resurfaced
reaches a
regions
place where
stand in
rock and
sharp
water remain
contrast
in
to the
conversation.
ancient, cratered
The
foreground.
core receives water,
The
reshapes it
northern
chemically,
regions of
and
Enceladus
returns it
reveal a
altered.
stark contrast.
It is kneaded by tides,
Ancient, heavily
warmed from
cratered
within, and opened by porosity to circulation. In that deep darkness, far below the bright ice and far below the visible plume, the moon's most enduring habitability may begin. The rocky core is the hidden engine that gives the ocean more than volume. It gives the ocean renewal. At this depth of the subject, a careful distinction becomes
In
necessary.
orbital resonance with Dione,
Enceladus may be
Enceladus
habitable,
undergoes
but
powerful
habitable
flexing.
does not mean inhabited. In planetary
The
science,
orbital resonance with
a habitable
Dione creates
environment
intense
is
tidal
one that
heating
appears
deep within
capable of
Enceladus.
supporting life as it is known from Earth. It may contain liquid water, useful elements, protection from destructive radiation, and a continuing source of chemical energy. These features make an environment promising. They do not prove that life is present there now, nor that life has ever appeared there in the past. The difference between these two ideas
These are
is
the
one of the
tiger
most
stripes,
important forms of scientific
active
restraint
fracture
in
zones in
astrobiology.
the south polar terrain.
Enceladus has become compelling because many of the standard requirements for habitability seem to be present together in one place. The Moon appears to have a global subsurface ocean beneath an ice shell. That ocean appears to contain salts, carbon-bearing compounds, nitrogen-bearing compounds, and likely accessible phosphorus. It appears to be linked to a rocky core where water-rock reactions generate hydrogen and maintain chemical disequilibrium. It may contain hydrothermal environments at the seafloor. Taken together, these conditions create a strong case that Enceladus could support life. Yet all of this remains a case about environment. It is not a direct observation of
Saturn's
biology.
E-ring is unique,
To move from
a vast
habitability
torus
to
of icy
habitation,
particles replenished by the
science
continuous
needs
eruption
evidence
of
of living
Enceladus's south
systems or
pole.
of unmistakable traces left by them. That evidence has not been found on Enceladus. No spacecraft has observed cells,
This fly-through
tissues,
offers a rare
colonies,
chance to gather
or metabolic
interior-related
activity.
material from an ocean
No
world
measurement
directly
has
in
revealed a
space.
chemical pattern that can only be produced by life, and not by non-living processes. No sample has shown a confirmed biological structure. The plume contains organic compounds, but organics are not life. They are ingredients or products of carbon chemistry, and carbon chemistry can proceed without biology in many places throughout the universe. This is why the presence
This
of
active
organics is
venting
exciting
reveals
but not
Enceladus'
decisive.
south pole as a tectonic
The same
gateway.
caution applies to methane, hydrogen, and other chemically suggestive compounds. On Earth, some living systems produce methane, and many use hydrogen. But methane can also arise through non-biological reactions, especially in
This stunning
environments
view
where
highlights
water
the
and
plume's
rock interact.
water-dominated nature.
Hydrogen can
Both
be
the vapor
generated
and the ice
abiotically, meaning without life, through known geochemical processes. Even complex organic material does not settle the question. Complexity alone is not enough, because non-living systems can build large carbon-bearing molecules under suitable conditions. The problem is not that these compounds are unimportant. It is that they are scientifically ambiguous. They fit life, but they do not require life. This ambiguity is not a weakness in the science. It is part of the science. Astrobiology works by building confidence step by step, and much of that work
These
involves
silica-rich
separating
particles
environments
provide the strongest
that look
evidence
promising
yet of
from
hydrothermal
environments that
activity.
can be shown to be inhabited. Enceladus has advanced strongly in the first category. It remains open in the second. That open status is precisely what makes it worth further exploration. A world that had already been proved inhabited
The
would belong
Cassini
to a
mission
different
revealed
stage of
Enceladus
inquiry.
possesses a subsurface
Enceladus
ocean,
still occupies the
indicated by the
threshold
surprisingly
between
thin
environmental promise and biological confirmation. There are several reasons why confirmation is difficult. One is access. The interior ocean is hidden beneath ice, and although plume sampling is a remarkable advantage, plume material may not carry every kind of evidence equally well. Some biosignatures, meaning signs that could point to life, might be too fragile to survive transport from the ocean to space. Others may be too diluted, too rare, or too chemically altered during ascent and freezing to stand out clearly in existing measurements.
The
A
plumes
plume
meant
gives
chemically rich
access,
samples from a
but
hidden
not
global
perfect
ocean,
access.
making
It
Enceladus
is
one
a
of the
window,
clearest ocean world
not a full
candidate in the
opening.
solar system.
Another
This
reason
cutaway
is that
reveals
life itself
Enceladus's
may
hidden
not be
ocean,
abundant even
a
in a
rich
habitable
source of
setting.
dissolved materials
On
far
Earth,
beneath the icy
suitable
shell.
environments do not always contain
Deep
large
beneath
or
the ice
obvious
of Enceladus,
ecosystems.
we find not
Some
just
are energy
water,
poor,
but the ingredients
isolated,
necessary for
or only
habitability.
sparsely inhabited. If Enceladus hosts life, that life may be limited to certain regions near the seafloor or in narrow chemical niches. It may exist at very low abundance. It may produce only subtle signatures that are difficult to detect during fast spacecraft fly-throughs. A habitable environment can still be biologically quiet. This possibility must be kept in mind because it means that failure to detect life immediately is
This
not the same
equilibrium is
as
central
proving
to
absence.
habitability, because
At the
usable
same
energy
time,
depends on chemical
the opposite
contrasts
possibility
rather than
must
chemical
also be
sameness.
respected. Life may simply not be there. Habitability does not guarantee biological emergence. A world can have water, energy, and ingredients and still remain sterile. The origin of life is not yet understood well enough to say how easily it begins when conditions are favourable. It may be common under the right conditions, or it may require rare chains of events. Enceladus cannot answer that question by environmental promise alone. Even a chemically rich ocean with hydrothermal activity might never cross the threshold into living systems. Science must allow that possibility without diminishing the importance of the Moon. This is why careful language matters so much. When scientists describe Enceladus as one of the best places to search for life beyond Earth, they're usually not claiming that life has already been found. They mean that the Moon combines several conditions thought to support life, and that it offers those conditions in a present-day environment that can be sampled indirectly through plumes. That is already a profound result. It places Enceladus among the most valuable targets in astrobiology, but the Moon remains a target of search, not a completed discovery. The difference between habitable and inhabited also
Deep
helps
beneath the
explain
ice
why
shell
strong
lies a global
evidence must
ocean,
meet a
where
high
water
standard.
circulates through a
An
porous,
extraordinary
mineral-rich
claim
core.
about extraterrestrial life cannot rest on one molecule, one ratio, or one suggestive pattern alone. It must survive alternative
Deep beneath the
explanations
waves,
based on
water
ordinary
permeates the
chemistry
rocky
and
core
geology.
through a vast
It must be
circulation network.
reproducible,
This-
coherent, and specific. In practice, this may require multiple lines of evidence that point in the same direction, perhaps unusual molecular distributions, isotopic patterns, cell-like structures, or
Deep
repeatable
beneath the hidden
signatures
sea,
of metabolism.
water-rock reactions
No such
release
complete
molecular
case
hydrogen,
exists yet
a
for
crucial
Enceladus.
energy source.
The current evidence supports potential, not proof. Within the inward path of this script, Enceladus now stands at its most delicate scientific boundary. It appears to offer the conditions in which life could persist, perhaps even flourish, beneath the ice. Yet it has not yielded a confirmed sign that life is actually there. This uncertainty
While
is
Mars
not
offers
empty.
clues to
It is
ancient life
structured
in its exposed
uncertainty,
basins,
narrowed by data and sharpened by the unusual richness of the Moon's environment. Enceladus is no longer just a speculative world of frozen possibility.
The essential distinction is
It
clear.
is a habitable
While chemically
candidate
rich
with
and
real
protected,
substance
this
behind the
remains a
claim.
world that may support
But the
life.
final step from possible life to known life remains unmade. The Moon holds that distinction carefully, and science
The
must do the
hydrothermal
same.
vents release plumes
Mars and
rich in
Enceladus
hydrogen,
invite the
evidence
search
that
for
makes
life in two
Enceladus a
very
strong
different
candidate
ways.
for ocean
Mars is
habitability.
larger, closer, easier to reach, and far more familiar in shape and appearance. It is a rocky world with volcanoes,
While Mars requires
canyons,
deep drilling for past traces,
sediment layers,
Enceladus offers
polar
direct
ice,
access to a subsurface
dust,
ocean,
and a
making it a
sky.
prime candidate for present-day life.
Enceladus is a small icy moon in the outer solar system, dimly lit and outwardly severe, with no substantial atmosphere and no visible liquid water at the surface.
Enceladus may matter
If the
more than Mars
comparison
for
begins
present-day
only
life
from
because it
appearance,
appears to combine liquid water,
Mars seems the
key
more
ingre-
natural place to search. It resembles the kind of planet on which life is already known to exist. Enceladus does not. This difference helps explain the long history of Mars in science and imagination. Mars preserves evidence that liquid water once flowed openly across its surface. Ancient river valleys, delta deposits, lake beds, and water-formed minerals all show that early Mars was wetter, and in many regions more clement than it is now. Billions of years ago, the planet appears to have held environments where water, sediment, and chemical gradients came together under a thicker atmosphere. These are the kinds of environments that can
How a
preserve
very small moon
biosignatures,
in a giant
meaning
planet
traces
system
left
can still
behind by
become
past
one of the
life
most
if life
compelling
ever
life
existed
search
there.
targets.
Mars is therefore a world of records. Its rocks may still contain a memory of habitability from a much earlier age. That strength is real and should not be understated. Mars is the best place in the solar system to search for ancient evidence of life in a surface geological archive. It offers exposed sediments, mineral layers, and former lake environments that can be studied directly by rovers. In terms of reconstructing a habitable past, Mars remains unmatched. It allows geologists and astrobiologists to ask whether life might once have emerged when surface water was widespread and the climate more favourable. That question is scientifically profound,
Mars offers
and it is
clearer
one
skies
reason
for
Mars
direct
continues
inspection,
to command
but the
such
subsurface
sustained
ocean of
exploration.
Enceladus may hold the
Yet
true
present-day
promise for
Mars
life.
is a different world from ancient Mars. The atmosphere is thin. Surface water is unstable in liquid form under most current conditions. The surface
The
is
question
cold,
is not which world is
oxidizing,
easier to
and
explore,
exposed to
but
radiation.
which one harbors the
Dust
conditions.
and dryness dominate much of the landscape. Although subsurface ice is abundant and some transient brines or deep groundwater may exist,
The
the most
comparison isn't
accessible
between a
modern
dead Mars and a
environment
living
on Mars
Enceladus,
is not
but
strongly
between two
favourable to life.
astrobiological prizes.
Any living system there now would most likely need to occupy protected subsurface niches where conditions are buffered from the harsh surface. In that sense, modern Mars asks science to search below the obvious terrain for a habitat that may still survive in limited form. Enceladus inverts this pattern. Its surface is even less hospitable than that of Mars in ordinary terms. It is colder, darker, and nearly airless. Nothing about the exterior suggests a friendly open environment, but beneath that frozen exterior, the evidence points to a global ocean that exists now. Not only in the distant past, that ocean appears to be protected by ice, supplied with chemical ingredients, sustained by internal energy, and connected to water rock reactions at depth. Enceladus therefore offers not a surface archive of old habitability, but a present hidden environment where habitable conditions may still be active. It is less useful as a museum of a vanished biosphere and more compelling as a possible ongoing habitat. This is the most important contrast between the two worlds. Mars is strong on accessibility and geological record. Enceladus is strong on present liquid water and protected internal chemistry.
These
Mars
smooth,
exposes its
resurfaced
past,
regions stand in stark
Enceladus
contrast
conceals
to the
its
ancient,
present.
cratered foreground.
The scientific choice between
The
them is
northern
therefore not
regions of
simple,
Enceladus
because the
reveal
answer
a stark
depends on what kind of
contrast.
life question is being
Ancient,
asked.
heavily cratered
If the goal is to search for ancient fossil-like traces in former lakes and sediments, Mars is the stronger target. If the goal is to search for a current environment where life might still survive beneath stable protection, Enceladus may be the stronger target. Radiation and shielding deepen the contrast. The surface of Mars receives far more radiation than Earth's surface
In
because the
orbital resonance
atmosphere
with
is thin,
Dione,
and the
Enceladus
global
undergoes
magnetic field
powerful
is
flexing.
absent. Over long periods,
The
radiation
orbital
can
resonance with
damage
Dione
complex organic
creates intense
molecules near
tidal
the
heating deep
surface
within
and
Enceladus.
make biological survival more difficult in exposed settings. Enceladus avoids this problem differently. It does not protect life with a thick atmosphere. It protects potential life by hiding it under ice. The shell blocks much of the harmful influence of space and preserves a more stable environment below. In that sense, Enceladus may be less welcoming on
These
the
are the
outside,
tiger
but more
stripes.
protective on the inside.
Active fracture
Energy
zones
also differs
in the
character
south polar
between the
terrain.
two worlds. Ancient Mars clearly had water and chemical diversity, but much of its greatest habitability appears to belong to early planetary history. Present Mars may still host localized subsurface energy sources, but those environments remain uncertain and hard to access. Enceladus, by contrast, appears to maintain present internal energy through tidal heating and water-rock interaction. Its habitability case is therefore not primarily historical, it is active. The Moon may be generating the water, chemistry, and energy conditions of habitability in the current era, rather than preserving them only as memory. Accessibility,
Saturn's E-ring
however,
is unique, a
complicates
vast
the
torus of icy
comparison
particles
again.
replenished by the
Mars is
continuous
much
eruption of
easier to land
Enceladus'
on,
south pole.
drive across, drill into shallowly, and sample directly. It has been visited by orbiters, landers,
This fly-through
and
offers a
rovers for
rare chance to
decades.
gather interior-related
Scientists can
material
choose
from an ocean
sedimentary
world
targets,
directly in
analyze
space.
rocks in place, and cache samples for return. Enceladus is farther away and harder to reach. Its most important environment lies beneath ice, even though its plume offers a rare opportunity for indirect sampling. Mission opportunities are still fewer and more demanding. The world may be more habitable in principle, and still be harder to investigate in practice.
This
Mars
active
benefits
venting
from
reveals
being nearer,
Enceladus's south
larger,
pole as a
and more
tectonic
tractable
gateway.
for robotic work. Still, Enceladus has one advantage Mars does not. It appears to deliver material from its hidden environment into space. This means that a spacecraft can sample signs of the ocean without having to reach
This
the ocean
stunning view
floor
highlights
or
the
melt
plume's
through the shell.
water-dominated nature. Both
Mars
the vapor
offers
and the
easier
ice
surface
grains
access but harder access to its deepest modern refuges. Enceladus offers harder travel but easier access to some interior material once there. This reverses intuition. The closer world is not always the easier place to test for present habitability. When the two worlds are placed side by side, the meaning of better becomes precise. Better does not mean simpler, closer, larger, or more Earth-like in appearance. Better means more favorable to the specific question of whether life could exist now in a stable environment. By that measure, Enceladus may indeed be better than Mars.
These silica-rich
Mars
particles
remains
provide the
richer in
strongest
exposed
evidence yet of
evidence of a
hydrothermal
habitable
activity.
past. Enceladus appears richer in the ingredients and physical setting of a habitable present. One world tells a story of lost surface conditions. The other may still sustain a hidden oceanic refuge today. At the innermost level of
The
this
Cassini
comparison,
mission revealed
the word
Enceladus
better must be
possesses a
handled with
subsurface
care.
ocean,
It does not
indicated
mean
by the
larger,
surprisingly thin
closer, easier, or more familiar. It does not mean more beautiful, more explored, or more likely to support human presence. In this context, better means more favorable to the existence and persistence of life, as it is understood from known biology. When that meaning is kept steady, the comparison between Enceladus and Mars becomes clearer. Mars remains one of the great worlds of planetary science, rich in evidence, rich in history, and central to the search for ancient habitability. Enceladus, however,
The plumes
may
make
offer the
chemically
stronger
rich samples
setting
from
for
a
life
hidden
in the
global
present
ocean,
tense.
making Enceladus
The
one of the
first
clearest
reason
ocean world
is
candidates
water.
in the solar system.
Mars
This
once had
cutaway
abundant
reveals
liquid
Enceladus's
water at
hidden
its
ocean,
surface.
a rich
Rivers
source of
carved
dissolved
valleys,
materials far
lakes
beneath
filled
the icy
basins,
shell.
sediment settled in
Deep
standing
beneath
bodies
the ice
of
of
water.
Enceladus, we
This
find
ancient
not just
record is
water,
one of
but
Mars's
the ingredients
greatest
necessary
scientific
for
strengths.
habitability.
But that strength belongs largely to the past. The modern surface is dry and cold, and stable liquid water is difficult to maintain there under current atmospheric pressure. Enceladus reverses that situation. It does not display rivers or lakes under open sky, yet evidence indicates that liquid water exists now beneath the ice. This present liquid state matters deeply. A habitable environment that still exists may be more
This
favorable to
equilibrium
living
is central
systems
to
than
habitability
one preserved
because usable
mainly as
energy depends on
geological
chemical
memory.
contrasts rather
The
than
second
chemical
reason is
sameness.
protection. Life as known on Earth does not flourish equally well in all settings. Exposure can destroy as much as it reveals. Mars offers open terrain, which is valuable for rovers and cameras, but that openness comes with radiation, oxidation, cold, and intense dryness. Any biology near the surface would face continuous stress. Enceladus places its most promising environment below an ice shell. This arrangement hides the habitat, but it also protects it. This same barrier that frustrates direct exploration preserves stability. It shields the ocean from much of the radiation and external volatility that shape exposed worlds. In that sense, Enceladus may be physically kinder to life even while appearing outwardly harsher. The third reason is energy. Water alone does not create a living world. A habitat must maintain usable chemical imbalance across long spans of time. On Mars, the most favorable energetic conditions for life may have been stronger in the distant past when liquid water, volcanism, and atmospheric activity were more pronounced. Some modern subsurface niches may still hold energy, but those niches remain difficult to confirm and difficult to
Deep
sample.
beneath the ice shell lies a global
Enceladus,
ocean, where
by
water
contrast,
circulates through a
appears
porous,
to maintain
mineral-rich
internal
core.
energy now through tidal heating and water-rock interaction. Its orbit continues to flex the Moon. Its core continues to
Deep
interact
beneath the
with
waves,
water.
water permeates the rocky
Hydrogen and
core
other
through a
compounds
vast
suggest that
circulation
chemical
network.
gradients are still
This-
being generated. This makes Enceladus not just a survivor of ancient habitability, but a candidate for ongoing habitability. The fourth reason is chemistry. Enceladus increasingly appears to offer a broad and useful chemical
Deep beneath
inventory.
the hidden
Its
sea,
plume
water
carries
rock
water,
reactions release
salts,
molecular hydrogen,
carbon-bearing
a
compounds,
crucial energy source.
nitrogen-bearing compounds, hydrogen, and evidence for accessible phosphorus. These do not prove life, but they do show that the hidden ocean is not poor in ingredients. Mars also contains organic compounds and important elements, and its rocks preserve a chemically informative history. Yet the present accessible surface environment on Mars does not combine those ingredients with the same degree
While
of
Mars
contemporary
offers
liquid
clues
water
to
and
ancient life
protection.
in its exposed
On
basins,
Enceladus, the chemistry appears tied to a living system of ocean, rock, and heat, rather than to a mostly desiccated surface record.
The essential
The
distinction is
fifth
clear.
reason
While
is
chemically rich and
internal
protected,
renewal.
this remains a
A
world,
world
that may
favourable
support
to life is not simply one that once had the right conditions, it is one that can keep refreshing them.
The
Enceladus
hydrothermal
seems
vents
to do
release
this through
plumes
the
rich in
interaction of
hydrogen,
shell,
evidence that makes
ocean,
Enceladus a strong
seafloor,
candidate for ocean
and porous
habitability.
core. Heat is not only stored, it is generated and distributed. Water is not only present, it
While Mars
circulates
requires
and
deep drilling for
reacts.
past traces,
Minerals are
Enceladus
not only
offers direct
buried,
access to a
They're
subsurface
brought
ocean,
into contact
making it a
with
prime
liquid
candidate
and
for
altered
present-day
over
life.
time. This gives the Moon an inward coherence. Its promising features are connected. The ice shell protects. The ocean holds water and
Enceladus may
dissolved
matter
matter.
more than Mars for
The
present-day
seafloor
life
and
because
core
it
supply
appears to combine
energy and
liquid
mineral
water, key
interaction. These regions support one another as parts of a single system. A sixth reason is access of a special kind. Mars is easier to reach and easier to explore in the ordinary engineering sense. That advantage is real and substantial, but ease of travel is not the same as ease of testing the central astrobiological question. If present life on Mars survives mainly in deep protected niches, then the most relevant habitats may still be hard to reach directly. Enceladus is farther away, yet it offers plumes that deliver material from its hidden environment into space. This does not solve every problem, but it changes the logic of exploration.
How a very
spacecraft
small moon
can
in a
sample the
giant
moon's
planet
internal
system can
products
still
without
become
crossing
one
a
of the
full
most
ice
compelling
barrier.
life search
In
targets.
that narrow but powerful sense, Enceladus may be more open to testing than it first appears. Still, the conclusion must remain measured. Better does not mean certain. Enceladus may be the better place for life than Mars, but that statement remains
Beneath this
about
icy
conditions,
shell, Enceladus
not
hides a
proof.
global ocean.
Mars may yet reveal ancient biosignatures or even modern subsurface habitats. Enceladus may possess all the ingredients and energy required for life and still remain uninhabited. The origin of life is not understood well enough to treat habitability as destiny. Science cannot honestly turn favorable conditions into a declaration of biology.
Mars
The
offers
uncertainty
clearer
remains
skies for
part of the
direct
comparison
inspection,
itself.
but the subsurface
Yet
ocean of
even with that
Enceladus may
caution,
hold the true
the
promise
balance
for
of the
life.
present argument leans in one direction. Mars is the stronger archive of habitability once achieved on the surface of a rocky planet. Enceladus is the stronger candidate for a protected, chemically active,
but which one
liquid
harbors the
environment
conditions?
that may still support life now. One world preserves a record, the other may preserve a refuge. One tells of rivers that are gone,
The comparison
the other
isn't
points
between
to
a
an
dead
ocean
Mars
that
and a living
remains.
Enceladus, but
One is
between
open
two
and
astrobiological bodies.
exposed, the other is hidden and sheltered. These differences do not make Mars less important. They simply clarify the special force of Enceladus. At the deepest level, then, the meaning of better comes down to continuity. Life requires time as much as matter and energy. It needs a setting that does not merely flash into habitability and vanish. Enceladus may provide that continuity beneath the ice, where water, chemistry, heat, and protection endure together. Mars still carries one of the great unanswered questions of ancient planetary life. Enceladus carries a different one, quieter but perhaps even more immediate. It asks whether a small moon in the cold outer darkness can maintain, in secrecy and stability, a habitat more favorable to life than the dry open plains of a planet, long thought to be the obvious choice. On present evidence, that possibility is no longer remote. It is one of the most serious and compelling ideas in the search for life beyond Earth. In the quiet distance beyond the warmth of the inner planets, Enceladus remains a small white moon turning around Saturn in a field of dim light. Its surface reflects the sun and gives little away. It appears simple from afar,
These smooth,
almost empty of
resurfaced
promise,
regions stand in
a
sharp
frozen body
contrast to
among
the
many
ancient,
frozen
cratered
bodies.
foreground.
Yet beneath that brightness,
The northern regions of
science now sees
Enceladus
a
reveal a
different
stark
order.
contrast.
Ice covers
Ancient,
water,
heavily
water
cratered
touches rock. Rock and motion maintain heat. Chemistry continues in darkness. What seems closed from the outside may still be open within. Mars remains close in thought because it preserves the outlines of rivers, lakes, sediments, an ancient habitability on a world more familiar to human eyes. It keeps the memory of open water under a sky.
In orbital resonance with Dione,
Enceladus keeps something
Enceladus
else.
undergoes
It
powerful
keeps the
flexing.
possibility of a protected ocean in the present.
The orbital resonance
comparison
with
does not
Dione
diminish
creates
Mars.
intense tidal heating
It simply
deep within
changes the
Enceladus.
center of
Keep-
attention. One world may tell most clearly how life-friendly conditions once faded. The other may show how they can endure in hidden form. Nothing in this conclusion proves that life exists beneath the ice of Enceladus. The ocean remains unentered, the seafloor unseen, the chemistry suggestive but not final. Still,
These are the
the
tiger
moon gathers
stripes,
many of the conditions
active
that
fracture
astrobiology
zones
seeks
in the
and holds them
south polar
together
terrain.
in one continuous interior system. Liquid water, useful ingredients, chemical energy, and long-term protection no longer seem scattered possibilities there. They seem joined, so the search grows quieter and deeper. It moves away from open plains and ancient shorelines and settles into the idea that life may prefer shelter over exposure, persistence over visibility, and oceans without sunlight over landscapes beneath a thin sky. In that calm shift of perspective, Enceladus becomes more than an icy moon. It becomes one of the most serious places in the solar system to ask whether life can begin, survive, and remain hidden in the
Saturn's
cold.
E ring is unique.